like the um I've got 3 different bits of homework that I could work on. And I think I'm going to start with complex analysis, but we've got options. Okay. Gotta go back to the Silksong grind? No worries. I hope you're enjoying it. I understand. With the following integrals around the unit circle. Well, for part A, isn't that analytic? Let's actually calculate it just to verify. Actually, can we calculate it? We might just have to use what's his face's formula, but let's just see if we can actually do it too. Hey, BR Gaming, I'm good. How about you? So, I mean, this is gonna get ugly if I do a polar substitution, though. Let's use a power series. And I just want to convince myself that it's 0. Binomial theorem, nice. And I guess from here we'll take z equal to r e to the I theta. dz, r is constant, and it's a 1, actually. So let's just do e to the I theta. e to the I theta, d theta. So slam an I out front, 0 to 2 pi. I'm going to interchange integration and summation because I feel like it. It's no longer a line integral, it's now just a regular integral. BR Gaming, I streamed regularly for 2.5 years. I'm now in grad school and have other priorities in life. If this actually paid me like a full-time job, I would go back to streaming regularly. But it doesn't make any sense for me to do that right now. Zero to 2 pi, right? Don't I get tired? That's just my existence. You get used to it. Hey, Collar Cone. Thank you, thank you. Happy Roblox birthday to you too. Where am I getting 0 in all this? I guess because these e's are going to come out to be both of them 1. This isn't the work that I'm going to like include with my homework, but I just want to be able to do this problem 2 different ways. The smart way and the dumb way. And this here on screen is the dumb way. So the point is n is just an integer, so this thing is always 1. This is just 1, so this is 0. That's what we expect, because e to the z squared is analytic. So I should really... Cauchy's integral... Not formula, but theorem, right? If you ever have a doubt something in complex analysis, just say Cauchy and you're probably right. Yeah. I just wanted to like verify it. Having the god or the good reflex. Yeah. And if it's linear algebra, you say Jordan. Okay, so that's pretty quick for part A. We can LaTeX this baby up quickly. Oh my god, this homework assignment could have been so much worse. Look at this giant question that got commented out. Thank god. This is where we're actually going. Since e to the z... Oops, I need dollar signs. E to the z squared is analytic. Do we care about on or just in? In, okay, I guess in the unit circle. Circle. Sounds like you should get some sleep, BR Gaming. Cauchy by Kawashi's. Like, frick, fuck, theorem. Hey, Skirtle. I know, homework. I'm such a nerd, right? Hope you're doing well. Page 83. Lowitz and Focus. Is that important to actually say disk? Is the disk the filled in version of the unit circle? Homework is for losers. Why don't just copy from smart people before classes start? You know, Skirtle, you're making a lot of sense. I like that color cone. Thank you. I'm gonna copy color cone's homework. Also, color cone, you need to register for my classes and apply to my school. By Cauchy's theorem. Oh crap! How do you do the closed loop integral symbol? Oh wait, I can just look. We're literally right up here. Oh, int. There we go. That makes that. That's a very literal notation, but I kind of like it. C e to the z to the 2 dz equals 0. How much is tuition? It's like 10,500 for a single quarter. So, you know, I hope you've been saving. Yeah. I think most of the students in my cohort are funded, but I sure as hell am not funded, unfortunately. But that's like when you're at the best Canadian university in America. That's actually a pretty good deal for a master's. You'll set up a GoFundMe. That means you can copy homework from each other. Thank you, Skirtle. I don't think Color Code will be able to copy much from me. He's a PhD student doing some math that's definitely beyond me, but Color Code never wants the wrong answer to things, and I guess that can work out. Am I really going to do partial fractions by hand here? I'm not going to do... No, I'm not doing partial fractions by hand. We all agree that we can do partial fractions, right? Just let Wolfram Alpha take care of this. Whoa, what the hell is this graph? That's kind of crazy looking. Oh, this is how... Ooh. I guess how vertical and horizontal lines map. Why does it do that? I guess I can kind of imagine why. Build webs so we can copy homework from each other. It's a great idea. I guess that's what we want right there. 1/2 z minus 2 minus 1/2 z. Analog map. Oh, that's, yeah, conformal map, right? It's like these are 90-degree angles at these intersections, is what you're saying. Just like these are 90-degree intersections here. I remember learning that in Penn Center's like Twitch complex analysis class. Why build them? We can use Discord. It's free. That's true, Skirtle. You're using your noggin. Oh, okay. So I guess the point of this problem is that one of these are analytic, the other one isn't analytic in the unit disk. And this one is just known to be 2πi. I feel like I can just cite that. It's a rare day my noggin is working. I guess like we could also say something with like this would integrate to log of z, and we our winding number is 1. You read an article about drawing equation. I mean, a person make equation which will lead to beautiful drawing on graph. Oh, nice. Yeah, there's some really nice looking graphs out there. Complex analysis can especially have a lot of them. I should probably... I think I probably should provide a citation. I know the book does this somewhere. Well, I would hope we... I don't... It's kind of bothering me that's a negative. I get... No, it makes sense that it's a negative. Okay. Equations only form? Oh, geez. Okay, from partial fractions, f of z equals slash frac z minus 2 equals... Hey, Stefan. How's it going? Slash frac 1, 2z minus 2 minus slash frac 1 2z. Fine, you guess? That's better than not fine. Tomorrow's the exam. Oh god, good luck. Those limits were super weird. It took me a while of looking at them before I could figure them out. Hey, Aditya. Then slash o int c slash frac z minus 2 is equal to slash frac no o int c. Oh, I need my dz. Think you got limits with, so I gotta go over two questions with functions and graphs. Okay, fair enough. Slash frac 1 2 z minus 2 dz minus slash o int c slash frac 1 2z dz. Okay. Again, by Cauchy's theorem, we find that this bad boy equals 0. Since the integrand the integrand singularity is outside the unit disk, so it is analytic. Hey Slim, Collar did congratulate me on my Roblox birthday. He would never forget. Yeah, Mouse. This way of integrating functions by counting the winding number and poles are really techniques. I never heard of techniques. Techniques, algebraic topology. Or is that, Google isn't a fan of techniques. I don't know. You weren't looping. Okay, no, it's just a similar sounding song. I thought the music was looping already. Where, I mean, we did it in class too, but I just want to, I guess, cite the book for the integral of 1 over z. Oh, it's a French word. Okay. Oh, techniques. I get it. There's a capital T, so I thought it was like a specific thing. Send you what you have to. Okay. Deformation. Yeah, we can talk about that. I'm just quickly trying to read Stefan's question 2. It looks like that one's going to be a bit more involved. So I'll talk about deformation first, Mouse. And then we'll take a look at Stefan's question. Some time spent reading the books, and it has been super helpful. But the class is going to go deeper than we got. Because we're already on. We've actually already covered some stuff from chapter 3. As like we just did Laurent's series, and we're on week we just finished, or we're just into week 3 out of 11 or so. Like we're gonna get, I think we're gonna do like chapter 4 and chapter 5, and I've never even read a word from chapter 5. Chapter 4 we did do. I still need to do a lot more work on Fourier and Laplace transforms. But yeah, so we spent all those months learning this stuff, and it's been really nice to have that base of knowledge. But the class is moving quick. Okay, so the idea about deformation mouse. No, this is like a PhD level complex analysis class. That's why I spent months studying for it, because I was nervous about like doing it. So deformation. The idea about deformation is we start from Cauchy's theorem, which I've noticed that different languages sometimes refer to the same theorem by different names, but Cauchy's theorem says that if f of z is analytic in a region D, then the integral of f of z around the border of D, C, called C, is 0. Exactly, yeah. So we'll just make our traditional blob. That's our region D. So it can be any region. It's not be a clean one. So if there's no singularities, the integral around here is 0. But let's say we do have a singularity. That's right there at the point z naught. How we can deal with that is we can find a region where it is analytic if we just do this deformation idea. So we make a little cutout in our contour, do a little circle around just to avoid the singularity, and then come back out to the contour. And this is okay to do because this entire region here, it's never going to contribute anything to the integral. And so, hey, look at, yes, I remember you. I also remember you asking that literally every single time you come here. So like this entire like region outside of the singularity, it doesn't really matter for the integral. It only ever gives you 0. So the idea of deformation is that we really only need to focus on this little bit here that comes from like when we circle around the contour. And we don't need to worry about these bits because we're going to take the limit as they get very close to each other and they're oriented in opposite directions. So they're going to basically be in the same spot, but pointing opposite ways. And so for a line integral, that means they just cancel each other out. And so for all intents and purposes, we can just consider like this contour here is the exact same as this contour here. Well, sorry, without this contour without the cross cuts. And this contour is much easier to work with. It's just a nice clean circle. That's the idea about deformation mouse. You're seeing Koshi's name again, Joseph? Yeah. Mouse asked about complex analysis, so Koshi is going to come up at some point. So unless you have a question, a further question, I'm going to take a look at what Stefan wrote. Example we could check and try. The contour around Western Europe. Oh, I remember hearing something about that moo, right? Or like that's like a common like meme or whatever. The poles, right? That's the joke. It should be easy for you, Stefan. All right. So mouse, I'll just like. It's kind of hard to show like a really good example of this, but like. If your function is f of z equals 1 over z, your contour can be anything it wants in the complex plane if it encircles z. Sorry, 0. So our singularity is right there. You can take any contour you want. Like it could be a box. It could be. I'm sorry. No, Stefan. I'm just finishing up Mouse's question. It should just be a minute before I get to you though. So sorry. So you could do a box. You could do a circle that's off-centered. You can do any contour you want that encloses the singularity, and they will all be equivalent to just this tiny circle here. That's the idea of deformation. And so I don't necessarily want to go through and like calculate the same thing like 3 different ways just to prove that point. But if you wanted to, you could do that. Or that might be a good like Wolfram Alpha exercise just to like program a few different ways, like a few different contours for this like integral here. Sounds good. Okay, let me look at Stefan's question. Looks like the formatting's a little bit weird, so we're gonna have to. I'm gonna have to ask you if I'm getting it right, Stefan. Oh wait, I see. Okay, you're providing the translation. Okay. This is gonna look a little messy at first, but we do. Have the image also. Oh god. Oh, okay. Three x minus 1. X plus 1 squared. This doesn't look like anything we need. X minus 1. Okay. So f of x is 3x minus 1 over x plus 1 squared. They're using the same function. I haven't... Wait, so I haven't actually read it yet. Domain, evenness, oddness, asymptotes, intercepts, sine, monotonicity, and concavity. Yeah, these are pretty related. The first one doesn't need calculus. The second one does, is the main difference, I think. Okay, so I guess first step, domain. And I guess I'm just gonna explain every part of this question unless you tell me otherwise. So just like focus on one piece of it. But my fate is in your hands now. A flying socks butt. Functions can have signs. Yeah, just like where it's positive and negative, I think is what they mean. The domain is going to be all real numbers except ones that break the function. And so this is a rational function. So the only way that the function kind of like breaks is if we divide by 0. And that only happens if x equals -1. So there's a lot of different conventions, both by country and by teacher, for how they want to hear about the domain. For some, it might be acceptable to just say x is not equal to -1. You could say all real numbers slash -1, which is like set notation. You could say -infinity to -1 union -1 to infinity. I guess, but if we're going by the European, actually, it's not all of Europe that uses this convention, I don't think, but this right here is the American convention, or at least I know that that's the one we use in America. Okay, sounds good, Stefan. Hey, Rex. Ads, black phone, nasty stuff. r/-1, your beloved. Oh yeah, syntax. It's a pretty good set. Okay, I see Stefan just posted it. Let's see what their notation is. Okay, so yeah, it looks like you're using this notation here then. Ooh. Oh, I forgot. Oh, that's stupid of me. I should it's gonna mess me up. Let me do that. So yeah, I guess the notation that they like is that. We went over construction of the reals today in class. Ooh, nice. I have not actually done that for myself, and I feel like I need to at some point. I know kind of the general idea. Yeah, exactly. Everything but -1. We're excluding -1 because of that denominator there. Like the general technique is to take the denominator and set it equal to 0 to find out invalid points. Thank you, Rex. And so like that's what you do for a rational function, at least. If you had like a logarithm, you just want to make sure you're not like plugging in 0 or a negative number. So like you don't want that instead. It depends on the function. If zero's in the numerator, that's fine. You just get like 0 divided by almost any number is just 0. The only thing to be careful is if there's 0 at the same time. Like 0 over 0 is just a weird case that it's a little more tricky to figure out. But in general, when you have 0 on top, it's just 0. 0 over 0 is not always 1. It can't. Well, actually, it's not anything. You cannot say 0 over 0 is equal to anything. There is the calculus sense of in the limit that this is 1. But it's not like you can't literally say that 0 over 0 is equal to 1 only in the limit. Yes. But well, even then it's only sometimes, because if I make this x squared, we now get 0. So that's why you have to be careful. It can be 1. It doesn't actually have to be 1. And actually, if I take the square and put it on the bottom, you would get infinity. Well, that's a little bit x cubed. Then you get positive infinity. So if it's 0, 0, just be careful is the moral of the story. It could theoretically be anything. Domain is all numbers except the one that breaks the function. Exactly that. We're going to the club? Hell yeah. And now, I guess for asymptotes. Let me look at the answer key, because there's vertical asymptotes and horizontal asymptotes. Ooh, they want both. Okay. Interesting. Okay, I see how they're doing it. All right, so there's 2 different types of asymptotes. You could have a vertical asymptote, which comes from what we just checked with the domain when we divide by 0. So in this function, we'll have what are asymptotes? They're basically a way of thinking about how the function behaves in certain weird cases. And so we kind of draw these lines to represent them. So I think it's easier to like see what they are from an example. So I'm just gonna tell you, there's a vertical asymptote at x equals, or like we're not allowed to plug in x equals -1. And this green dotted line represents the vertical line x equals -1. Vertical asymptotes, these are kind of like they were described to me as like jail bars when I was first learning these, where you cannot cross these because of this like domain issue. We'd be dividing by 0. And but they do tell you about what's happening around this asymptote, because when we're like right next to it, this is a very small number. Like it would be like, if it's like, I guess, -0.9999, you're going to end up with a very small number in the denominator. And when you divide by a small number, you get a big number. Which, that sounds like really weird, but it's an important thing to remember. The function goes to it, but not over it. Right. And so around vertical asymptotes, you kind of blow up to positive or negative infinity. You could get both sides going the same way, going up. You could get one side going up, the other side going down. You're going to always go like up or down to infinity, though. It just kind of depends on the function itself. Now, horizontal asymptotes, and I see these vertical asymptotes in the answer key are abbreviated as BA. In the notes for XA for horizontal asymptotes. Horizontal asymptotes, they're not as strict. They kind of tell you about the long-term behavior of the function. Spoiler alert, we're going to have an asymptote at y equals 0 for horizontal one, which we'll actually find this later, but just to show you like what this means. Horizontal asymptotes, you are allowed to cross these. Like there's some functions that would do a thing like here, like where like they dip above it and then they come back down to it. So you are allowed to cross these. What they tell you is as you go far to the right or far to the left. Oh, yeah, sorry. I hope that's better. If it's really like messing with you, the YouTube stream doesn't have music at all. But yeah, let me know if you want me to turn it down more though. Yeah, flying socks, but it's exactly that. So yeah, horizontal asymptotes, they tell you as you go far to the right of the graph or far to the left, how the function, like what the function tends toward, I guess. So like the function could look like this, where it's getting super close to 0, but not quite. The farther we go off to the right, and we could also have like this, where it's getting super close to 0 from below as the farther we go over here to the left. That's what a horizontal asymptote tells you. So I started with that explanation because this will hopefully make more sense for why we're about to do the thing that we're about to do next. Yes, that's a good question. So the first step for vertical asymptotes, these always come from like holes in the domain. So we have a hole at x equals -1. We already found. So that's our vertical asymptote for this problem. Exactly. Yeah. And so it looks like the answer key, to me, like that already would be like the answer. We have a vertical asymptote at x equals -1 for that piece of the question. But I do see the answer key actually gets the behavior around it, which is helpful for graphing. So we can figure out. Yeah, exactly. There could be multiple vertical asymptotes. Like, if we instead had x plus 1 and x minus 1, we'd have 2 asymptotes now at plus and minus 1. And so the answer key, it does actually figure out the behavior around this asymptote, like, because we do care whether it goes up to infinity or down to minus infinity. It's not, we still know there's an asymptote, so I don't feel like it's strictly necessary, but just to show you like what they're doing here, they're figuring out like that piece of the problem. So we're gonna need to do 2 limits. We need to approach -1 both from the left and then also from the right. I guess we can start with left, because why not? 3x minus 1 over x plus 1 squared that is used for the second question where they ask you to draw the graph. Yeah, yeah, it's going to be helpful there. I don't know why they do it in this part of the answer, but it will be helpful for drawing the graph. This is me just kind of like mirroring the answer key for this piece. If I was doing this myself, I would just leave it at like vertical asymptote at x equals -1, and then we do need to do limits to figure out the horizontal, but because we'll need to figure this piece out eventually anyway. I guess we'll just do it now. You can do just one because it goes to -infinity. Well, we don't know that yet though, syntax, right? So we already know this limit is going to be infinity of like plus or minus. The only thing we really care about is like, is it plus or minus? But by the nature of being a vertical asymptote, we know it's going to go to infinity. So the way we figure out the sign is figure out the sign of the numerator and the sign of the denominator. So in the denominator, we have the squared. Anything squared is always going to be positive. Maybe you could do just one limit of syntax error thing. It's not making sense to me right now immediately, but I feel like it depends on the numerator. This way, well, it might be extra work, but it'll definitely always work. So I'll show you like the general way of doing this. So yeah, so the bottom is squared, so anything squared is always positive. And then in the numerator, we're plugging in things just above -1, or I guess below. So like we're plugging like -1.1 or -1.0001. That's what it means to approach from left, like. And when we plug in numbers like that into the numerator, we're getting 3 times that negative number minus a 1 is still a negative number. So on top, it's negative. On the bottom, it's positive. So a negative number divided by a positive number is negative. And that's how we figure that piece out. Can you plug in 2 and -2? Those are too far away. You don't have to actually like calculate things, but you should be thinking about numbers that are like a little bit closer to -1. That's the right idea though. Yeah. You run into like, especially +2 is all the way over here. The function could, like, a different function could be doing something completely different there. So yeah, exactly. If that 3 was something else, well, I guess if this is like a +1, maybe we'd have to be a lot more careful. Or like there's some other version of this numerator where we have to be a bit more careful. This one's just kind of forgiving, I think. But it's something like that. Yeah, exactly. That's the exact like type of logic. We don't care what the actual number is. We just want to know if it's positive or negative. Yeah, exactly. Yeah, good. And so we'll do the same thing with the limit from the right. Some type of infinity. And so now going from the right, that means we're plugging in numbers like -0.999. So as always, the denominator is positive because of the squared. The numerator is something, it's 3 times nearly -1, but it's like, 3 times -0.999 minus 1 is still negative. So by basically the same logic, we're going to get another -infinity. Closer to -1. Like we're trying to get just on each side of the vertical asymptote here. Minus from both sides, exactly. So yeah, so the function is going to do like something like that. We don't know, like, it could be shifted up or down, but we know around this asymptote, they're both pointing down, is what we've just learned here. So we find the horizontal asymptotes from the long-term behavior of the function. And that all that means is the limits to plus and minus infinity. So we're the limit as x goes to positive infinity to show going to the right. 3x minus 1 over x plus 1 squared. Just check with the answer key. That's kind of interesting. They figure out whether it's from above or from below. Yeah, so if you know what to do that limit, like we could save some time and not actually evaluate it if you can just see what that's going to be. But if you want to see me calculate, I can do that too. Go through it? Okay. There's one little piece of what they've done here that is kind of interesting. I'm not quite sure how they figured that piece out. Or maybe that means something else. Okay, so the way that you usually do a limit like this for a rational function, actually, for this part, it's going to be more convenient if I expand out the denominator. So let me do that off to the side. Thanks for skipping a lot of steps. Oh, okay. So if we expand out the denominator, we get x squared plus 2x plus 1. So I'm going to use that instead. So if we try to plug in infinity here, how did I do that? I just expanded x plus 1 squared. That's all that's happened so far. My professor is teaching trig sub. It's not the most fun thing. No, trig sub is kind of annoying, Art. Good luck. And so I'm doing that because it's going to make the next step easier, basically. Because I know it's about to come next, so I'm saving a bit of work here. And so the way that I was taught to do these was kind of like by intuition. I'll show you the way that your professor is doing it. But for me, I could just look at this and see that we're going to get 0. Because on top, the degree is 1. That's linear. On the bottom, the degree is 2. So in a sense, the bottom is a bigger number because it's degree 2. And so when the bottom is bigger, dividing by a big number gives you 0. So I would just be able to look at this and see that it goes to 0. But there's a way to actually show this too, which we'll go through. 3x minus 1 over x. This is valid to do. I don't see how it makes it easier. But if that does somehow make it easier for you to evaluate that, that's allowed to rewrite it like that. Hey, Super Twitch, +3, -3 to the top. Oh, that's kind of clever. I want to show the way that Stefan is intended to do this problem. That is kind of a neat way to simplify it, though. So yeah, I think the way it looks like you're intended to do this limit is also another common way to do these limits to infinity, which is to factor out the highest power you can from the top and from the bottom. So from the top, the highest power we can factor out is just a power of 1. So x times 3 minus 1 over x. The highest power on the bottom is x squared. So 1 plus 2 over x plus 1 over x squared. Oh wait, I shouldn't have added a new page. I guess it was fine. The point of doing this is that we'll get a cancellation that x will cancel with one of the x's on the bottom. So we get just 3 minus 1 over x for x times 1 plus 2 over x plus 1 over x squared. You don't think they really care about if I did it the same way as them? Oh, really? Okay. Honestly, it's a little bit of work. This is the most straightforward way to do it, though, I would say. Hey, JC. Stupid Twitch has a clever suggestion. It can be kind of hard to spot it, though, which is why I don't necessarily like recommend it to everyone. Well, I would say this honestly is the simplest way that'll work every time for this type of function. I can tell you a different way of thinking about it too, though. After this, because we're nearly there with this limit. The point of doing this manipulation is that these limits or these pieces become very easy to evaluate because 1 over infinity is essentially 0 in the limit. So that is not 1, that's 0, that's 0, and that's 0. So one thing we really need to care about is like the 3, the 1, and the x. Like the limit's essentially the same thing as 3 over x, with like the 1 also being there. In this case, it doesn't matter though, because this is still 0. In other cases, those coefficients might matter. Here, they don't. So I say that means the limit is 0. So the other way of thinking about these types of functions is how should I explain this? Oh yeah, yep. You it's just that's essentially the other thing that I wanted to show you. Unless you know like how to think about infinity here, though, it can get really confusing. Doing this piece first can hopefully make it more straightforward to plug in infinity from the start. If you know what you're doing though, you could skip straight to plugging it in here. And so it's not too hard to know what you're doing with that. So I can show you some general, there's basically 3 rules to remember if you're plugging in infinity from the start. So the first rule is the one that, no, it's not that simple. It's only a little bit more complicated, which is instead of infinity over infinity, think of it as infinity over infinity squared. Because this is a linear function degree 1. This is a quadratic function degree 2. We have more powers of infinity on the bottom than on the top. Dividing by a... you can think of it as like... This is really bad math. Don't actually do this, but you could kind of cancel out one of the infinities. So it's like 1 over infinity, which is 0. So this is a lot quicker way to get the result that we just found. In general, if degree Q is bigger than degree P, JC, I believe that is always right. Yes. I want to make it so I don't have infinity on both sides, I guess. Like, I just want to have it at the bottom in this case. Yeah, like, infinity over infinity, we don't, like, not all infinities are created equal, is the issue. You have to know, like, what type of infinity you're dealing with. Because you could also have something like, limit as x goes to infinity of x over 2 to the x. This is infinity over infinity, but you're going to get 0. And I can just tell that because I know exponential functions grow faster than linear functions. And the same reason here, quadratics grow faster than lines. It's all about the rate that they go to infinity. And so that's why it's not as simple as just saying infinity over infinity is 1. Yeah, exactly. Like, it's like a race to infinity, where like if you have a line like that, it's gonna get to infinity but slowly, whereas a parabola, it's getting to infinity so much faster. Just like looking at these pieces here is the important bit. Yeah, and so that's the second case. So I said we're gonna have 3 cases in total here. The second case is what you do when the degrees are equal, and so I'll take JC's example here. 2x over x plus 1. This one is just basically infinity over infinity, because degree 1, degree 1. The rule here is you take the leading coefficients. So 2 over 1. Maybe I should just be clear. Make that a 3 there. So we're taking this 2 and this like invisible 1 here. So just 2. So if the degrees are equal, you do get a finite limit. That's true because if you have a line with slope 1 and a line with slope 2, no matter where you are on the graph, this line is always like twice as high as this line if you take like a vertical slice like that. Like this point here is twice as big as that point there. Yeah, exactly. Like how many times you have infinity on each side. And so, like I said, like doing math like this is really, it's not correct but it is intuitively correct. It's not mathematically correct, but like it gets the intuition across. Yes, exactly. That's Stefan. And so the third case is basically the flip side of this case, where what if we have degree 2, or even like we can make it degree 3 just for fun, over say degree 2. Yeah, exactly. 3x over 3 plus 2x. That would give you 3 over 2 in the limit. Yeah, and what JC is saying is true too. So in the third case here, we have degree 3, so that's like infinity cubed. Below, we have infinity squared, degree 2. So if we were to do this non-correct thing and cancel infinities, we would get just infinity. And so cubics grow faster than quadratics, so it makes sense that we get infinity. And the cubic is on top. So yeah, I would not recommend you turn in work like this to like a teacher or anything, but this is a good way of making sure you're getting the right answer. And that's why I wanted to show you the other way of doing it too, because this is actually like correct work. Same would be 4x cubed plus 1, x squared plus x squared. Yes, you would still get infinity there too. Exactly, yeah. Sounds like you got it. Okay, and so the thing that was confusing me about the answer key is that for their 0, they had like a little plus there or minus, and I'm not entirely sure what that part meant. So I'm just gonna kind of ignore it. It might mean like, I noticed the plus went with the limit to positive infinity, so maybe it means that. But they could mean something else by that too, so I'm not entirely sure. Now, horizontal asymptotes are a little weird because this is only half the problem for horizontal asymptotes. We should also think about the limit to minus infinity. I think it's possible to have two different horizontal asymptotes. Like I think you can you? I feel like it's possible to have like a function that goes like that, where there's a horizontal asymptote of like +1 or whatever, and a function that goes like maybe like that with like a different horizontal asymptote there. I feel like it's possible, maybe it's not. The more I look at it, the more I think it's not possible. It's not I'm googling it actually because I'm getting less sure the more the more I talk about it. Oh, so you can have multiple horizontal asymptotes. Okay. So I guess functions like this exist. So we should check both limits to positive and negative infinity. And it's kind of looks like the asymptote, like it only applies to one end of the spectrum. I guess where like this horizontal asymptote down here doesn't say anything about what's going on the left side. It only says something about the right side. Yeah, exactly, Stefan. Um, uh, here it makes no difference. So we can do the same exact manipulation. Just gonna speed run through it. 1 plus 2 over x plus 1 over x squared. These all go to 0. So I'm gonna do a little like squiggly thing for the one is basically x to minus infinity 3 over x. So yeah, the reason it doesn't matter here is that we're still getting 0, and 0 isn't positive or negative. So like we're essentially getting negative 0, but that's just 0. Yeah, and so I did the squiggly lens because this step isn't like I don't know if I'd actually write this on like my work, but we can I'm trying to say that we can ignore like this entire piece here because it all just goes to 0. It can matter in the second two cases here. Is the idea. So if I took like the third case here and we think about negative infinity instead, now we're plugging in very big negative numbers. A negative number cubed is negative, so we'll have a negative number on top. On the bottom, we'll have a negative number squared, so that'll flip to positive. So then we have negative on top, positive on bottom. I would expect to get negative infinity here now. And I think the same logic would apply here. We'll have negative on top, negative on bottom. So I think we still get positive infinity. We can verify that with Desmos. Um, 2x over x plus 3. Oh, I'm sorry, I said infinity. That's not, sorry, it's positive 2. Yes. And it looks like that is true. So like we could draw the line y equals 2 here, and it is the same asymptote. So that checks out. So that changes. Oh, I didn't catch the one you said the just that changes bit, but those were the signs and asymptotes. This was just the asymptotes, to be honest. Our answer is that we have asymptotes at x equals -1 and y equals 0, is what all of this has told us. we needed to do these limits down here, like this limit and this limit, to find the horizontal asymptote, potentially to two of them. We only had one though. This limit we didn't have to do, but it'll help us draw it later. But yeah. Okay, so that's the asymptotes piece. Hey Sage, thank you, thank you. Oh wait, I skipped over the evenness oddness part. I'm sorry. I don't know why I went straight to the asymptotes. We should check for symmetry. So we check for symmetry. I guess if a function is even, which is one type of symmetry, that means that f of negative x is equal to the original function f of x. Graphically, a parabola is even because if you split it, I'm sorry, I should say specifically y equals x squared is an even function. And that's true because it has this like vertical axis of symmetry where this piece is a reflection of this piece. So it's kind of that like horizontal flipping. No, this isn't JJE Hibbit. So when we have is it could be or it could not be. We need to do this to test it. I'm not sure yet, to be honest. It probably won't be. I doubt it's going to have either type of symmetry. So I guess, yeah, it is possible for an answer to be neither as well. I think it's going to be neither. An odd function satisfies this equation. F of negative x is minus f of x. And how an example of that is x cubed. And here we're kind of symmetric around just a point, the origin, because you would do like this piece here is like two reflections of this piece here. Like we reflected horizontally and then flipped down to reflect it vertically. This is easier to like show in person, but yeah, that's the idea with even in odd functions. The thing you actually need to do is just plug in negative x into the original function and see what you get out. No, this is completely unrelated to asymptotes. They might be symmetric around an asymptote. It is possible to be symmetric around an asymptote. We don't call it even or odd, though. That's just a different type of symmetry that they're not asking about. Right. We don't care about asymptotes here. I mean, they are kind of helpful because the fact that we have an asymptote here is going to screw up any type of symmetry we try to look for. So actually, just knowing we have the vertical asymptote, we can be pretty dang sure it's not going to be even or odd. Yeah, okay, I'm sorry. If that's what you mean. Yeah, the asymptote is going to break the symmetry. Okay. Yeah, that's fair, Spawn. That's a great way of thinking about that. Zach, E2pi, thank you so much for the raid. I hope your stream was good. Anyone here on my end, please check out Zach. He's awesome. Hibbit, this is the problem here at the top of the page. Hey, Rob. Carlocone, hello. Kevin does chemistry. Hey, E to the pi times raid. We're just working on this problem on the top of the page here from Stefan. And hey, Femvox. But yeah, we're working on this problem from Stefan. We were just working on some complex analysis homework, which we'll go back to doing that once we're done with this question. But yeah, so we have a rational function, and we're kind of getting all the information we can about it. Yeah, I peeked on your stream, Zach. I don't remember what you were streaming about though, because the stream has been a blur for me, but I hope it was good. This one, yeah, Stefan. The way we can tell for sure is to plug in negative x. So everywhere we see x here, we're gonna plug a negative x in instead, and just see what we get out. So 3 times negative x minus 1, negative x plus 1 squared. Lots of things, fair enough. And so we can make this look a bit more normal. We can say it's like minus 3x minus 1 over 1 minus x squared. This certainly is not the original function, so it's definitely not even. And this also isn't negative f of x. Negative f of x would be like that, which these don't match either. You could do it for a specific number x, yes. You could get unlucky and find 2 points that happen to match, I think, even if it's not symmetric. So I would recommend using just a general number x and messing around with it. If you try it with like, if you try it with 1 point, you're probably okay. If you try it with multiple points, then you can be a lot more sure that you're okay. I think the negative x way is the best way, even though it's a little bit weird to get used to. This is a throwback. Yeah, this is like a pre-calc or algebra 2 maybe type of question. I remember doing this in high school. Should I play PS5 just to play Ghost of Yotei, or is that ridiculous? I've wanted a PS5 for so long to play Bloodborne. It is a little ridiculous, but if you can afford it, you know, I think you should do it. So yeah, it's basically like, it's what we drew here, where it's a reflection across the y-axis has to look the same. If you mean like the actual like plugging in negative x thing, the simplest example is if f of x equals x squared. If we do negative x here, we get minus x squared. Which I guess if I show every last step here, we can rewrite as minus 1 squared times x squared, but minus 1 squared is just 1, so we get x squared back out, and those match. You hate the controller for the PS5 so much I stopped playing it? Oh, really? I've hardly ever used one. I've heard they're pretty small though. Yeah, I mean, Sony has ported so many of their exclusives to PC, but not Bloodborne. Which is so annoying. But, you know, I didn't play Ghost of Tsushima, but they both look like really cool games. So I have to rotate your wrist in to hold it. Oh, fair. Symmetric joysticks is a bad thing? I wouldn't think that's a bad thing, but maybe a misunderstanding. Very much? Oh. Like, my Xbox controller joysticks are the same. Oh, for odd? Yeah, yeah. If x cubed is the simplest example of an odd, because if we do f of minus x, we'll get minus x cubed minus 1 cubed x cubed. Minus 1 cubed is minus 1, so we get minus x cubed. So this is the negative version of our original function, so that means it's odd. Oh, that's true. F of x equals x is the easiest one, but that's a little bit too easy. So you might have to do some like manipulations to make them look the same. Like, when you have more complicated functions like this one, you should mess around with it and just shuffle some signs around and see if you can make them match. And then only if you can't do it, declare that it's neither, or like say that it's neither. And I guess another thing I'll throw in, if I just threw in a +1 to this function, I would break. Oh wait, no, I wouldn't. If I threw in an x here, I would break all of the symmetry. It wouldn't be even or odd. So just because it's a parabola doesn't mean it's even or odd. Parabolas always have some type of symmetry because of the way that they look, but it's not specifically even or odd. GameCube had it best. I use the GameCube controller a lot. I don't remember, like, I guess it's okay. I don't know of a controller that I've actually like been like, I love this. Yeah, Stefan. So that's a pretty smart way of thinking about it. Where like knowing there's a vertical asymptote here, is gonna break any type of symmetry that we could hope for even or odd at least. The positive infinity on the y-axis. I don't know if that would do. I don't think we would know it from any of these limits that we did before. Because those are, I mean, maybe. I guess, yeah, kinda. Can't be odd if it goes to infinity on the y-axis. Well, it's not going to infinity on the y-axis. It's going to infinity on -1. You could have an odd function. 1 over x is odd, and 1 over x looks like this. So just because you're going to infinity doesn't mean you can't be even or odd. Does that mean it would be possible to be odd or even with 2 vertical asymptotes? Yeah, I think if we had like evenly spaced vertical asymptotes, we could go back to being even or odd. Like if we had one at -1 and one at +1, we have a chance again. Because positive infinity on both sides of the y-axis. We're getting negative infinity, right? Well, so I guess like, yeah, so around the vertical asymptote, we know they're both pointing down. I mean, you can just look at that and see that it's not going to be even or odd too, I guess. But I'm pretty sure we're getting the negative infinity for that, right? Whenever x counts as odd functions, since -0 is equal to negative infinity and 0 equals infinity. Oh no. Gotta have both sides of the coin to spend it. A fun case. That's true. Just draw everything as I get it while doing. Yeah, graphs are really helpful for all of this. Oh my gosh. Okay. We we're 60% done with the first question. We need to find intercepts and then the sign. Okay. So if we want to find x-intercepts, the x-intercept is where it intersects the x-axis. So we're trying to figure out when it crosses the x-axis here. That means we're going to set y equal to 0 and solve for x. Or f of x, I guess. Set y equal to 0 and solve for x. Or f of x equals 0. But whatever your notation is. I guess here we're using f of x. But like, basically, we want to solve this equation here. And the way that we do that, exactly, yeah. And so some people get confused with the denominator. We can safely ignore the denominator here, as it turns out, because you can never divide by something and end up with 0. Like try, if you have like the number 2, try dividing by a number to get 0. Like, you just can't do it. And no division by 0. So really we care about the numerator. 0 equals 3x minus 1, and we want to solve this. Not necessarily. It could be a function, because remember, we have this horizontal asymptote here, so it could be a function that, oops, we're going to negative infinity, right? It could have no x-intercepts if it looks like that. It could have one x-intercept if it looks like that. So we just don't know until we solve it. Oops. We're gonna end up with just one here, though. So add 1 to the other side, divide by 3. We're gonna get x equals 1/3. So that's good to know, because that gives us a clue about, like, we have a really good idea of how this thing should look now, because we only have a single x-intercept, like, right there or so. And so we're getting an idea of how the function, like, I can already guess the function is going to look something like this. Just capturing the information that we know about the asymptotes and the intercepts now. This is a pretty sloppy, like, line here, but because there's an intercept there, we're going to have to go from negative infinity and cross up to the intercept and then come back down to the horizontal asymptote. We do need to find the y-intercept also, though. Go towards 0 and y, but never touch it. Yeah, and so it, in the long run, you never touch it. At least it's okay if you, like, if you touch it at first, it's okay. Like right there, it's okay if we touch it. But as we go farther out to the right, we shouldn't touch it. Horizontal asymptotes are kind of weird like that. Okay. Okay, good. So then for y-intercept, set x equal to 0. And solve for y, or f of x. So, oh my gosh. Well, I guess f of 0, really. So that's 3 times 0 minus 1 over 0 plus 1 squared. That's 0, so we get negative 1 on top over 1 squared is negative 1. No, we still have the plus 1 there. No worries. We've been doing a lot of math, so a mistake is going to happen. So now from the first one, we know we have a point 1/3 comma 0, and from what we just did, we also have another point 0 minus 1. So those are two helpful data points. Off by 1 error, the classic. The last piece of this question is the sign of the function. Okay. So normally, actually, let me look at the answer key to see how they do it. Okay, yeah, that's what I thought. So they normally make something called sign charts, which is just a number line. And these represent X values. And we're trying to figure out, like, when could the sign potentially change? Like, when can the function go from positive to negative or from negative to positive? And the only place where that can happen is across vertical asymptotes or at x-intercepts. So the thing we care about for our chart here is x equals -1 and x equals 1/3. And now we can figure out the sign of the function basically by plugging in test points to the left of -1, between -1 and 1/3, and beyond 1/3. But you don't need to actually calculate it, you just care about the sign. And we already have huge hints for this because we already did the work with the limits. Because we already know around -1, we're going to negative infinity. So we know around here, we're going to have negative numbers. Yeah, exactly. Those are great test points. Yeah, we already know what f of 0 is too. But so like from either that or the stuff we do with the limits, we know we have negative here, negative here. And then we just need to do like f of 1 as a test case and just don't even actually calculate it, just figure out what the sign is. 3 times 1 minus 1 over 1 plus 1 squared. Well, that's a positive number on top, positive number on the bottom. So we get a positive number overall. Bracketing like artillery. Oh yeah, that's a thing, right? There we go. Yeah, the thing you want to avoid is I don't think it could happen here. I was thinking it might be good to check it anyway in case the oops. Like the function could be really tricky and like do a little bouncy thing or something, but I don't think this is actually possible. But I just want to make sure it couldn't have like bounced off the intercept in some way. I shouldn't be a worry in this case, but like just in case I wanted to like check that piece. Since we know what the horizontal asymptote is, I don't think it's possible, but yeah. It looks like in the answer key, they gave actual like the notation version of what we just did here. So we can say f of x is positive for x greater than 1/3. Actually, no, they're doing interval notation. So 1/3, comma, infinity. Yeah, exactly. You could also just check for all of them. And we know f is, negative for x in minus infinity, -1, union, -1, 1/3. A bounce requires simplifying to an even power? Yeah, I think so. But because of the horizontal asymptote, that shouldn't be possible. Flying sucks, but I was just kind of like being safe. It's not defined at the asymptote. It's just a hole in the function. So it's not really positive or negative. Yeah, we know how it behaves around there. Like you could think of it as being negative there, but it's not really. You shouldn't talk about the function at -1 because you can't really say what it actually is. well, like exactly. You can say it's negative infinity, but that's infinity isn't a number. Okay. Whew. Oh, good. I'm glad to hear that you think you could do it now. Second one should be easy peasy now. I think this is going to be a shorter question. Okay, so the song Skull and Keys by Radar. Radar is really good, like Halloween music. Oh, you know, it means that it's really boring. You know, it's monotonous. No, monotonicity means it's always increasing or always decreasing, or saying the same, depending on the person. No, the midnight. That's true. Although all the midnight songs kind of sound the same with like the saxophone. So if we want to check monotonicity, we make a sign chart like we just did, but for the first derivative, f prime x. For concavity, we make a sign chart for f double prime x. That's going to be our approach here. Yeah, exactly. Flying socks, but primes? I don't like prime numbers. I don't think we have to worry about those here. I don't know what you mean though. Oh, primes are like derivatives. I'm stupid, dude. Yeah. Ugh, okay. Sorry. Yeah, this is it's a really annoying one too. But that's just what the question is making us do. You don't know the rules? Oh. All right. We need quotient rule. Yeah, there are a lot of primes in math. So if you have f of x equals to p of x over q of x, f prime x, it's low d high. So q of x times p prime x minus high d low. So p of x q prime x over q of x squared. The quotient rule sucks. It's not our friend, but we have to use it sometimes. Yep. The mnemonic. Archgottle, thank you for the follow. The mnemonic or whatever I use to remember this is low d high, as in derivative, minus high d low. And low means denominator, high means numerator. It's just a formula that you have to know, unfortunately. And so we'll see how it's applied here. Prime minus 1 is 0, right. So in this example here, p is 3x minus 1. Yeah, just multiplication. Q is x plus 1 squared. So p prime, the derivative of 3x using power rule is just 3. The derivative of negative 1, as you said, is 0. So we get just 3. QP, yeah, exactly that. And then for q of x, we need the chain rule. Oh, good. We start. I didn't lose you yet. Okay. we start by taking the derivative of the outside function of that squared. So if we had just x squared, the derivative would be 2x. So when we have x plus 1 squared, the derivative is 2 times x plus 1. But then because of the chain rule, we have to multiply by the derivative of x plus 1. Luckily for us, the x goes to 1, the 1 goes to 0. We just get 1. Chain rule you don't know about. Hey, Joe's best right, man. Yeah, this is like a Calc 1 question, I'd say. So you've never seen the chain rule at all? Like for f of g of x prime? Do I have too many parentheses? I don't know. I think I'm okay. No? Okay, well, let's do it a different way. You know this, but you don't understand it? Okay, well, if you're allowed to use it, it's good to learn. Yeah, I can help with differential equations. This is the only question I'm working on right now, and then I can help you out. If you want, you can post it in the Discord server if that's easier, or you can put it in Twitch chat. Okay, so Stefan, the chain rule helps you deal with functions inside of other functions. So I want to think of an example that's not too scary. I'm going to modify what we have here. If we have 2x cubed plus x squared, we want to take the derivative. I think of it as starting from the outside and working my way in. On the outside, we have this squared. Oh, yeah? Awesome. Yeah, feel free to post it in math discussion or math homework help. Right. And this is just an example that I made up here. Exactly that, though. You stated it right. If we want to, this is a really good one to use the chain rule on. It can save a lot of work. You could, if you wanted, multiply this squared out and do things individually, but the chain rule saves a lot of time. So it's good. It's good to know here. So think of it as like outside functions and inside functions. They want us to know anyway. Okay. So the outside function is a squared. Like that's what's outside the parentheses here. So if we had just x squared and we want to take the derivative of that, we would just bring the 2 down and make the exponent 1. So 2x. So we're going to do the exact same thing here, except instead of an x, we'll have whatever's inside. So 2x cubed plus x. Exactly, yes. What I just did was f. The inside part would be g. Like this thing inside here is g. Lucas, I'll get to you in a second. And so now the chain rule says we have to multiply by the derivative of the inside now. Exactly, yes, you got it. And so this first piece, we use the power rule. The 3 comes down to multiply. So 6x squared, and then the x becomes 1. And that's our result. Are partial differential equations the same as part of a PDE, or is it part of an ordinary differential equation? PDE does stand for partial differential equation, if that's what you mean. Partial differential equations are different from ordinary differential equations, but often you have ways of translating partial differential equations that are really hard to solve into ordinary differential equations that are easier to solve. So they're related, but they are different things. You can go from one to the other. Do 20 different types of chain rule problems by yourself once you learn it, then you'll be fine. Yeah, basically, as Appen says, like, it's a lot of practice. How do people come up with this? I don't know. This is Newton and Leibniz, and I know that Newton at least was a freak. So, I don't know. Leibniz probably was too, but I don't know. All right, so yeah, we got the chain rule. This situation here with cubex was an easier case. So we just get 2 times x plus 1. Now we can just play everything into the quotient rule. Yeah, exactly. And so the x prime is just 1. So you're technically doing the chain rule there, but yeah. Kind of tripping at maths. I feel way stupider than before. But I got 95 on my test, so I guess I'll take that. I feel like the more you learn math, the more stupid you feel, not the smarter. Because you also kind of defined a new operation, which is both dividing and multiplying at the same time. That's kind of interesting because those are like inverses. You would think that's not accomplishing much. Okay, so we have everything we need now to find f prime x for the actual f. So going over to this formula here, we have q x plus 1 squared times p prime 3 minus the original p, 3x minus 1, times q prime 2x plus 1. Oh god, this is terrible. Over q squared. But q is already x plus 1 squared, so we get x plus 1 to the 4th. This is why the quotient rule sucks, because you get things that look like this. Honestly, this is a nicer case relative to some of them. But yeah, so now we're kind of stuck needing to simplify this. So let's hack our way through it. There is one saving grace here, which is I've noticed that we can factor an x plus 1 out from the numerator. So let's do that. So we get this. I also proved that a less than -1 greater than b. Oh, for your wedge stuff. Okay, nice. It's been a minute since we've talked about that. I lost you again? Okay. Yeah, this is just getting into mind-numbing algebra here, so I wasn't really explaining it. But yeah, that's all that happened. I factored an x plus 1 out. Because I want to cancel it. And now I'll multiply out the 3x plus 1 and the minus 2, 3x minus 1. So 3x plus 3 minus 6x plus 2 over x plus 1 cubed. And then group like terms. Minus 3x plus 5. Oh, that's ugly. That's what we get though. Okay. All right. X cubed minus 1. That? No, that's just a different thing. Like you want to make it into x cubed plus 1? That's a completely no. Like these aren't the same thing. I can show you why. The parentheses are important. I don't want to do it by hand, but if you multiply out x plus 1 cubed, you do not get x cubed plus 1. You get this. So, yeah, be careful of the powers. If there's a addition inside the parentheses, you cannot just get rid of the power like that. I also tried defining something new so you can do stuff with infinity and get total valid infinity numbers repeating 2 numbers in a row. Huh. I'm not completely following that, Lucas, but yeah, that could get interesting. Okay, let me just see if okay, Joe joined the Discord. I haven't seen Joe's question get posted yet. But Joe, if you ever do post your question, just let me know. I feel bad making you wait, so if we need to take a break from this question, I'll do it. But until I see it, I'm gonna keep on working on this one. Okay, so we have everything we need for the first part of the question. Yeah, so we can answer the monotonicity and we can answer extreme values. I should say extreme values, set f prime x equal to 0. And for inflection points, set f double prime equal to 0. There you go. Pascal's triangle, yeah, flying sucks, but x plus 2 squared is also the same. You don't have to multiply x and 2 with themselves. Yeah, exactly. Mr. Space Smiley Face. It's been minutes since I've seen your name around. Thank you for the kind words. Monotonicity means the function is always increasing or always decreasing, or staying the same. So let's start by finding the extreme values. We're going to take the thing we just found for f prime and set it equal to 0. So minus 3x plus 5 over x plus 1 cubed equals 0. For the same reason as last time, we can just throw out the denominator. And thank you so much for the prime. That's very kind of you, Mr. Space Smiley Face. Thank you. Positive or negative, Lucas, but yeah, exactly. Or 0. Actually, some people define it to not include 0. Some people do. That's a matter of opinion, but yeah. So we're going to throw away the denominator. We only care about minus 3x plus 5 equals 0. So we get x equals 5/3. Yeah, because Lucas, you could have a function that like it like flattens out just for a second and then goes back to increasing. So like this function is always increasing except right at 0 where it flattens out just for a second. And so depending on your opinion, you could call that monotonic or not. I think different people have different conventions. Yeah, just like the only way you can get 0 from a fraction is if we have 0 on top. We can never get 0 from the denominator. Yeah, it would like break it. So x equals 5/3 is an extreme value. And so now we can make our sign chart for the monotonicity. And the only thing we need to care about is the extreme value. Actually, the opposite. Extreme values are where it's a minimum or a maximum. Usually. So if we had, like, I'm going to draw a generic cubic function here. Right here is an extreme value because it's a maximum, like locally. And right here is an extreme value because it's a local minimum. So it corresponds to where the tangent is horizontal, basically. Now there is a weird case where it's neither. Well, yeah, so that's why I said locally. It's like for the points around it, it's at a maximum, like immediately around it. Of course, you know, it gets an actual maximum like off to infinity, but just like immediately in the area. Like relative to its neighbors, it's the maximum. My opinion, that's true because no matter what interval you choose, f will always be increasing. Yeah, like it's not x cubed that does that, but it's something like x cubed. So but like you have to be careful. You have to make the sign chart because it is possible to have functions like I was just talking about with Lucas, where it just like it temporarily flattens out right at one point, but then it goes back to doing what it was doing. So you would get an extreme point right here if it does indeed like actually flatten out there. I didn't quite draw it perfectly. This is a critical point too, but it's not a minimum or a maximum. So that's why extreme value. So that's why it's like kind of complicated. That case is a bit more rare. I think it's like x to the 1/3, maybe, or no, it's not. I don't remember what the example of the function is, but there are functions that are like that. Yeah, Femox, the YouTube stream is on. YouTube's been quiet for a while though, which is probably for the better. Yeah, it's I would say it's neither a min or a max rather than both. I'm just trying to say it's possible to be an extreme value, but not be a clean like minimum or maximum, I guess. An interval, we were using intervals before, like 1,2 is an example of an interval where like all the points between 1 and 2. We have had one JE mentioned so far, but that's about it. And so yeah, Lucas is saying that like Lucas is saying like another way of thinking about that like local minimum or maximum thing. Or like we can find an interval where for the other example I drew earlier, you could make an interval from like here to here where that point is the maximum. I think is what Lucas is saying. But over here you can't do it, but it's still an extreme value. So we had an always positive function once, so it's not strictly increasing because it's not continuous. Ooh, that's kind of neat. Ooh, I did. Okay, you know what? That's so good that you mentioned that, Mr. Space Smiley Face, because I just realized I made a mistake. or at least I omitted something. So when I made the sign chart here, I said we only have to care about extreme values. I wasn't correct though. We need to worry about vertical asymptotes also. So x equals -1 is a vertical asymptote here too. So we also need to worry about that. So this is actually the sign chart we need to fill in. And so we're going to plug in values for f prime x now, right here. And again, this is, we just care about the sign, not the actual value. So if we think about like -2, we're going to get -6 up here. Sorry, we're going to get -1. And then we're going to get some negative number cubed, which is still negative. So we're going to get... Wait, really? I'm sorry. Yeah, you caught my mistake. It's going to be 11 on top, right? And then on the bottom, it'll be -1. So I said not to calculate it, and then I calculated it, but this is a negative number. So we get decreasing here. And then I guess 0 is a convenient point to plug in for between. So we get 5 over 1 cubed, so that's positive, increasing. And then over here we can plug in 2. Here's our -1, and that's over 3 cubed, which is positive. So that's negative. Yeah, good. There might still be an issue since we can't define two numbers following each other up. Therefore, we can choose an interval AB does not have an extreme value, or does have an extreme value. Yeah, Lucas. So the answer to the monotonic piece is f of x is decreasing monotonically on x belongs to -infinity -1 union 5/3 infinity. Basically this end of the interval and that end. And then f of x is increasing monotonically. I think I'm phrasing this weird. I think we should, put monotonically in front, and I'm putting it after. I don't know how to spell monotically. I am too lazy to spell it right. I'm sorry. I'll spell this one right. -1 5/3. We do completely different. Yeah, I don't know. The different places have their own conventions. I was kind of actually I didn't look at the answer key for this one. Ooh, that's a weird sign chart. What the hell? Oh god, yeah, the answer key does so much unnecessary work. We got the right answer though. Last week it was pretty piled on. This week is a bit lighter, thankfully. You'll do it like this? Okay. I have all the homework like pulled up so I can actually like show you too. For each of my three classes, I have like 2 to 3 problems each that are like of a decent size. Like they're not small problems, but they're not massive. Nice try. Like x to minus infinity. Oh, I think I've seen stuff like that, Lucas. Yeah. Yeah. It has to be something with 7. All right. Mercifully, we're almost done here. We just need to we need to take another derivative, but we're gonna do the same exact thing again here for f prime for f double prime. $27 is not a real number? I'm pretty sure it is. Do not upset the penguin today. Well, yeah, be careful if you go to the zoo, Lucas. Okay, so um I really don't want to do the quotient rule a second time here. Would you hate me if I just use Wolfram Alpha to find this derivative? Because it's really just the same thing over again. And I really don't want to do all this algebra. Also, if you don't know about Wolfram Alpha, you should, because it can just find the derivative magically like that. No number is real since we assign big things to random names. I mean, yeah. There are no nut numbers after 3, it's just dot dot dot. Send the name caret to something with billions of electrons. Yeah, that's true. Using it to cheat? Yeah. Basically. So I really don't want to. You would have to do the quotient rule a second time, and I just don't want to do it. So I'm going to use Wolfram Alpha's answer. You should like try it though to make sure that you can do it. Oops, I copied it down slightly wrong. Or you should make sure that you can do the quotient rule, but I mean it's the same thing that we set up earlier here. So it's the same like formula and the same procedure with like, you know, getting your P's and Q's. Or don't and just cheat. Say sorry and they'll forgive me. All right, if that works. So yeah, so inflection points, ooh. Is -1 an extreme value? I think it can't be. Mind your P's and Q's. The derivative does change signs around -1, but -1 isn't a point on the function. So I don't think we would call it an extreme value. Do they call an extreme value in the answer key? I don't think they do. Okay. So, now we want to find points of inflection, which is the same exact thing as an extreme point, but for the second derivative. Well, it's not the same thing. It has a different interpretation, but it's the same procedure. We take our second derivative, set it equal to 0. And then ignore the denominator again. Triple dot k of a vector made triangle. I know of a triple product with vectors. I don't know if that's That doesn't make sense though. I don't know what you mean by that. I'm sorry. No, the bear I chose didn't win, unfortunately. I just thought of something. Is ever useful to find a function k of x such that y squared plus y plus 1 equals x, then k of x equals y? Well, you're calling it a function. This statement k of x equals y isn't. I'm not sure what that means. If it's a function of x, but then we have a y here. So I'm not quite sure what you're trying to do with that, Lucas. There are like. Oh, you meant like an x there? You could definitely have something like y squared plus y plus 1 equals x, or even like something else like x cubed plus 1 or something. All right. Good night, mouse. Thanks for being here. It'd be called a relation instead of a function. That's a more general like word for it. And they are useful. Y squared plus y is better. Yeah, that works too. Oh yeah, I said it equal to 0, so that's how we find points of inflection. We can divide the 6 from each side to get, and then add 3 to get x equals 3. So we have 1 point of inflection here, potentially. Good luck with that, mouse. But yeah, look, so you can definitely like play around and have like, you can even have like sine of y equals x squared plus 2 or whatever. It'd be called a relation instead of a function, but that's allowed, and sometimes you need stuff like that. And so yeah, now the same procedure, we make a sine chart with both the point of inflection and vertical asymptotes. So -1 and 3, and then we do test points again. So with -2, negative number divided by positive is negative. Continuity something something? Maybe? That's a little vague. Between -1 and 3, we'll plug in 0. There, yeah, like, look spelled up continuity, or like asymptote. Point of inflection. Asymptote. Okay, well, the story of this part of the question is we took another derivative. I cheated and used Wolfram Alpha. You would have to use the quotient rule. We set it equal to 0. We found that x equals 3 is a point of inflection. And now we're setting up a sine chart to find the concavity of the function. And the sine chart needs vertical asymptotes with -1 and the point of inflection with 3. Oh, concavity is the word? Yeah, so this is the concavity piece. So this minus sign means that it's concave down. A concave down function looks like this, where like it opens up downward. Concave up opens upward like that. And so a point of inflection is where it changes from one to the other. So like this piece here is concave down, this piece here is concave up. So there's a point of inflection somewhere around here where it changes. Yeah, smiley face and frowny face, exactly. Enochian, thank you, thank you. Hope you're doing well. So yeah, and then for this interval, I'll try x equals 0. Negative, positive. So negative. So when yeah, it's a frowny face. That's a really funny way of remembering it. I like that a lot. And you're frowning while you do it, yeah. Then finally we'll try x equals 4 for the last piece. That's going to be positive. And so that kind of makes sense with how with what we were saying. Because we were already able to guess the graph of the function way earlier. That it would look something like this. Sorry, I got a little bit wrong. More like that. And so this checks out with all we did with the derivatives. Like this piece is decreasing. This piece is increasing, and then it goes to decreasing. And then for the concavity, this is concave down. This is concave down. And this is concave up. So it kind of checks out. How do you call it when you have a double derivative? Whole and bull? You be right back? Okay. Oh, it's one of those questions, Star. We can try it. So yes, Stefan, I hope that makes some sort of sense. I want to take a look at Star's question. Joe didn't seem to have posted his question. Well, I mean that always kind of depends on it's basically this. You can be a bit more exact. X equals -1. Y equals 0. We can include, we know this is a point. We know the other intercept was that like 1/3? 0, I think. And basically from here, we can fill in what we know it looks like from the derivatives and stuff. Something like that. Yeah. Benlux is calling the answer for Star's question. Okay. You're gonna get this piece of information up here too, and because I'm too lazy to delete it. Just ignore the piece on top. Actually, you're gonna get the entire file, including the stuff up here too. Ignore the stuff that's not relevant to you. The alphabet in Arkansas, the impossible dream? What? Passionate new romance appears in your life when you least expect it. Well, that's a nice one. I don't get the Arkansas one. Are they too dumb to know the alphabet? Is that the joke? Okay. Let me just at Joe. Okay. Let me take a look at Star's question. Okay. Okay, so for the first ship, it's sailing at 17 kilometers per hour. I think this is easiest done giving the first ship a head start. That's what makes sense to me, at least. And so rather than having them start at the same point, so I guess what they've given us in the problem is both ships start from the same point at different times. Like both ships are right here at the origin. In my brain, at least, it's easier if they start at the same time, but different points. So like ship 1 is right here and ship 2 is right there. So I would say that the first ship like has the point at time 0, the ship has traveled 34 kilometers. And for the second ship, at time 0, it's still at base. You once had a dream, a monster asked me what the square root of 1,000. When I woke up, I had to find the square root of 10. I used a facto's concave down and linear approximation to find it between 1/8 and 1/6. Nice. I would think about it as like being between 3 and 4. As like those are the next nearest like squares, or like 9 and 16. It's like just a little bit above 3. So the equation for the first ship, we can set up like, if you know like point slope form for a line, y minus y0 equals slope x minus x0. I'm going to use that here. So y minus 34 equals, the slope is the speed, 17, x minus 0. Then we can simplify this. 17x plus 34. And then for the second ship, it's y minus 0 equals 21 times x minus 0. So it's just y equals 21x. And they're asking it basically at what time the second ship catches up to the first. In math, we would... that means we're basically going to equate these two things. They're both equal to y, like 21x equals y and 17x plus 34 equals y. So let's set them equal to each other. to find where they intersect. So I'm getting, subtract the 17x over to get 4x equals 34. X equals 34 over 4, which is 17 over 2. Which is 8.5 hours, which is what Fenlux got to. Nice. So I hope that makes sense, Star. Let me know. Sup? Yeah, what's the question? Thank you for the follow. Oh. So feel free to post it in math discussion or math homework help. Okay, so Lucas, you asked a question before you left. You know why you're speaking French? How do you call it when you have a double derivative and you check where the double derivative is bigger or less than 0? Um, I think you're talking about like concavity, which is like how the function is shaped. If it's more than 0, it's concave up, and the function looks something like that. It's not necessarily exponential, but it does mean like it's really just talking about like the shape here. And if it's less than 0, it's concave down, so it's something like that. Change. No worries, that's understandable. I hope you're enjoying Silk Song. It's going good for me. I hope that you've been well. Hey Puika. It's so much better than what you call it. Oh, really? But yeah, so then you have a function that's like sometimes one and sometimes the other. So like this bit here is concave down. This bit here is concave up. Hole and bull. I still don't know which is which. Oh no. Uh, what question do you mean? Like which one do you want to talk about? Yeah, there's just give me a number. Someone is bull in Dutch, at least he's fat. You can throw that belly in the concave down direction. You know, if it works, it works. 4B? Okay. Oh, I guess it was a good thing, Shaner. Thank you. Concavity slash convexity is defined even without derivatives. It can prove concave functions are continuous everywhere and have one-sided derivatives. Oh, interesting. Oh, what the hell is this? Uh... Come on. Why is it taking... Why is the screenshot thing not working? What the hell? It just crashed on me. I never had the snipping tool crash on me. What the hell? Zoom? Or I'm going to be working on here. Anyway. Create a diagram, state all the givens. I don't really know what to draw. Like, the givens are just the speeds and the 2 hours later. I don't really know what they want for a diagram, though, Star. Just like, I guess they just want you to, like, draw actual ships. One's going at one speed, one at the other, but I don't really know. Okay, yeah, I sort of start, but I don't really know like what your class would actually need. Like I'm not sure I can help out with that piece. All right, so the sphere is, wait, the cylinder is radius 8. Okay, so we know cylinder radius 8. Sphere is radius 17. Okay, this isn't so bad. So we want the height of the cylinder, and we have a really convenient way of finding that. If we form this right triangle here, that's half the distance there. So the cylinder and the sphere had the same center right here. And so we just get this really nice, like, right triangle, I guess. I could also, like, I could also have drawn, like, the radius of the sphere right here, or, like, anywhere that goes out from the center to the sphere. But, like, the helpful one to draw is, like, one of these that goes up to the cylinder. Because we know that the radius of the cylinder is 8, so really we just have a right triangle here. One leg is 8, the hypotenuse is 17. We can use the Pythagorean theorem to find the remaining side. So we know that 17 squared, I'll call it b, is equal to 8 squared plus b squared. I don't know what 17 squared is. $17 squared is 289. Equals 64 plus b squared. Subtract 64 from each side. We're going to get 522 equals b squared. Now we square root each side. So we get b equals root 225. And if you know your perfect square as well, you know that's 15. If not, use a calculator. So we know this distance here is 15, and this is the center of the cylinder, so we know this is half of the entire height of the cylinder. So the entire thing should be 2 times 15, which is 30. So I'd say that's the answer for part 1. Between total surface area and volume, so volume is 3-dimensional. It's the amount of space that something takes up. So like to use a sphere as an example, like how much space does that sphere actually take up in our like 3-dimensional world? Surface area is you look just at the surface of that sphere and calculate the 2-dimensional area. It exists in 3 dimensions, but like area is just a 2-dimensional thing. So like you know what? There's a better way of talking about this. Donkey. Okay. This is a sheet of paper. You could calculate its area if you cared to, just like pretending that it's a rectangle, do base times height. I could also, yeah, exactly, length times width. I could also take this piece of paper and fold it into a tube. And if I do it just so that the ends meet, ugh, I shouldn't. This would be a lot easier for something like binder paper, but if I fold it into like a cylinder just so the ends meet, the area of that rectangle is the same as the surface area of this cylinder. This cylinder doesn't have caps. Like there's nothing on each end, so it's a little bit like different. But that's really what surface area is. Like imagine flattening it out in 2 dimensions and calculating the area. Whereas the volume, you would imagine this thing is filled in and you find out how much space that takes up. So that's basically what surface area is. Like it's a 2-dimensional thing. You always have like 2 lengths multiplied together in some way. And then volume, you have 3 lengths. And so which part don't you understand? So I'll get back to the geodesics someday. Yeah, that'd be nice. I guess about like the volume being like liters thing, or the next, okay, yeah. So we can get, or we can talk about this one. So so we could just blindly do the math here. So I guess let's start by just like blindly doing the math, and then we can talk about it, about like what it means. So they want us to get the volume of the cylinder as a percentage of the volume of the sphere. So what they want us to do is get the volume of the cylinder, and divide it by the volume of the sphere. That's what it means for the cylinder to be a percent of the sphere. You need to do division. So the volume of a cylinder, it's weird they give us one formula but not the other. The volume of a cylinder is a question. It's pi r squared h, right? I should verify this, but yes. Okay, good. I was about to say that K parts, but I think it's pi r squared h. And so we know the radius is 8, and the height we just found is 30. So we can plug in here. Pi times 8 squared times 30. Pi times 64 times 30. I assume you have to use a calculator for this, but I think that's 142. 0. No, I didn't do that right. I'm using a calculator. 1920. You can calculate the area of a 2D figure by taking smaller and smaller grids and counting the number of grid cells. Can approximate its circumference in the same way. Oh, and I'm being a little bit sloppy here. I don't know how picky this test is about it, but I didn't include units. Let me go back and include those because they do give us units, and I know that some people are very picky about units. Everything was given to us in centimeters. Oops. On the outside we have squared. Okay. So we get 64, then centimeters squared times 30 centimeters. So we get pi, oops, we get 1920 times pi cubic centimeters, because that centimeter squared times that centimeters gives us cube. And so volume should always have a length cubed. So centimeters are a length. We have centimeters cubed. That checks out. Now let's get the volume of the sphere. They give us the formulas 4/3 pi r cubed. So 4/3 pi. The radius is 17. That's definitely work for a calculator. And again, I'll remember my units. 17 cubed times 4. 19,652. Over 3 pi. And then again, we have centimeters cubed, or cubic centimeters. Okay, and now the last step is to divide the two things we just found. So we get 1920 pi centimeters cubed over. And if you're allowed to use a calculator, you can just make this a decimal and make this a decimal to make this next part easier. I don't know what the conventions are for this test in particular, so I'm just doing everything as fractions. But if this part is going to get confusing to you, just make it a decimal. But this is something that we can plug into a calculator. The units cancel out, which is a good thing. we wanted that to happen. The pi's cancel out too. So we get 1920 times 3 over 19,652. $14.40 over. Wow, what a terrible number. We'll use the decimal version. I'm just going to copy this down. So that's the fraction, but they want a percentage, so we want to go to the decimal. 0.293 we'll estimate it as. And to make it a percent, multiply it by 100 and stick a percent sign on. So 29.3%. And I'd say that's our answer here. That's surprisingly low. But it's not drawn to scale, so that makes sense, I guess. And so this answer kind of checks out because the cylinder is smaller than the sphere. So it definitely shouldn't be like over 100%. Like if it was 200%, that means the cylinder is twice as big as a sphere, and that wouldn't make any sense with the drawing. So the fact that we're getting something that's like less than 100% is good. Yeah. So I hope that makes sense. Up. Let me know if you have any questions. Otherwise, I'm going to move on. Then you Pythagoras in the last one, because we had a right triangle here. We know that like this line here is perpendicular to that line there. You posted the same thing in a few places in Discord. I'm going to delete a few of these just to keep things clean. Yeah, like the right triangle was hidden from you, and they wanted you to spot it. They're now been the same without the units included. The number would be the same. I was just including the units to be careful because I don't know how picky that whoever grades this test is. I didn't include the units on the first bit, but that should be centimeters. But yeah, so like tests like these, they love to hide right triangles in places, so it's always good to keep an eye out because right triangles are just so easy to work with relative to other shapes. Okay, so unless there's any other questions, I might finally get some time to go back to doing homework. The next one, I can look at it. Okay, yeah, this one isn't too long. We can do it. I think this will be the last one that I want to do from here before I move on to something else, but we can do this one. Um, how do you do this? So they give us the entire cube has length 20. That's gold. Yeah, he probably do this in a flash. Um, I know the idea at the end is going to be to like subtract the volume of the sphere. I'm trying to figure out how we get the initial. What are we subtracting from? I guess yeah. The volume of the cube or yeah, by the water plus sphere, right? It's like basically the entire volume of this shaded in box, including the sphere, is what I'm gonna find first. Um, and that's 15 times 20 times 20. If they're picky about units, I'll include those. That's work for a calculator. Actually, no, it's not. 60,000, 6,000 cubic centimeters. Yeah, so we will remove the sphere in a second here, but I think this is a helpful thing to get first. Oh, okay, yeah, I think I see the idea. And then, so the volume of, so the volume of just the water is what we want to find next. And that's going to be the thing we just found. Water plus sphere. Plus the volume of the sphere. Oh, sorry, minus. So, this is a little bit like roundabout. The thing we're really interested in is what's the new height of the water after we take the sphere out. Because the water level is going to go down, of course. But we need to do that through finding the volume of things. So we will get to the actual question soon. We just need to figure out what the volume is first. So once we remove the sphere, we take the total volume and subtract off the volume of the sphere. So the total volume is 6,000. The volume of the sphere, I guess I'll do that separately. 4/3 pi radius of 15. What? Wait, is there a shortcut? So I'm basically I'm trying to get the volume of the water after we take the sphere out. Radius 6. Oh, thank you. Oh my god. So Right now what we have is the total shaded volume of everything, including the sphere and the water. I want to get the volume of just the water, though. So I'm going to subtract out the volume of the sphere. That's the idea of what I'm doing here. So I need to calculate the volume of the sphere quickly, but once I do that, I'm going to take the total minus sphere, and that'll be the volume of our water. Happy nightmares. Hey, hope you're doing well. Happy nightmares talks about a lot of things on her stream. One of them is math, though. But also there's like a bunch of things. It's hard to even describe, but like she's an interesting person. You guys should check her out. Are they different densities? I don't think we have to care about that. I guess I sure hope we don't. 4/3 pi 6 cubed. I need a calculator. 6 cubed times 4/3. 24. Nope, I did that wrong. 288. I'm getting like mentally tired. Okay, so 288 pi cubic centimeters. And so this will be the volume of the water. This is more work for a calculator. 6,000 minus 288 pi. $50.95.22. I'm going to go to estimates here. 50.95.22 cubic centimeters. Okay, and so the nice thing about this, like the entire point of this approach is that we know the volume of the water. Sorry, the volume of the water. We just found it as being 50.95, but we know it's also 20 times 20 times whatever the new height is after we take the sphere out. We'll call that h. So 20 times 20 times h. And so we know it's also equal to 50.95.22. So we can just solve this for h. 20 times 20 is 400. Now we divide each side by 400. Sorry, I messed up the units. We can divide each side by 400 square centimeters. So these centimeters cancel out entirely, the 400s cancel out entirely. Centimeters squared cancel out with most of the centimeters cubed, just leaving one behind. And then we'll plug that last bit into a calculator. Uh, 12.74. So that's the new height of the water. And that this does make sense. Like 12.74 is less than the original of 15. If we got something like 16 or 20 or whatever, we would know that we're definitely wrong. So that's like a nice way to do a sanity check that your answer makes some sense at least. Sure, could we divide the sphere's volume by 400 square centimeters? Really? I don't see it. Uh, like what part's up? Because I just went through the entire problem. Like which part did I lose you on? Give you the opposite. The water level will drop by. Oh, yeah. That okay. That's kind of weird. But I think that's another way of doing that too. Yeah, you're basically like taking that sphere and pounding it out into a rectangle. So yes, up. If you want to say which part you didn't get, let me know. But otherwise, if I don't hear anything more specific from you, I'm just gonna move on. Okay. At least for now, I'm gonna go back to doing something else. But if you're still typing something out or thinking about it, just put it in chat whenever you think of it, and I'll come back around. More in Blue Book? Yeah, that'd be nice. Uh, yeah, like just like doing homework, Lucas. But if you had a question, let me know. So the very start of the stream, I was doing complex analysis homework. It's up to you. If I really wanted to like get this done, I just wouldn't stream it. What are you in the jackpot if you pick 7 out of 7 numbers, 1 to 25 correctly? You make 330 a week as a TA, and tickets cost $3 each. Sound like a very realistic word problem here. So when you spend all your money on lottery tickets, how many years on average do you have to play to win and retire? Um, far longer than a lifetime. Yeah, I don't think that's too bad of a probability question. Lucas, this is like a complex analysis, it's called. So it's all about like imaginary numbers and calculus. Oh, K-pars, I'm sorry. Probability unit quiz last year. That's funny. Um, so the probability of winning once is 1 in 25 to the 7, right? I should write it a little bit neater. And then we can afford to buy 110 tickets each week. So whatever that comes out to be, let's Wolfram it. So that's the probability of winning in a particular week. How many years on average do you have to play to win? What's the expected value? Is it just 1 over this? How does expected value work again? Is there a way you could define a function with an operator in it like sigma? For reverse sigma? For like summation? Summation is difficult because it's hard to invert that. Like if you have a summation that results in like 2, there's infinitely many ways you could write 2 as a sum of things. It's like, how do you choose a particular one? For n times p. Oh, okay. Oh wait, so this is the expected value, right? Yeah, dude, I'm really rusty on probability. Oh my god. But I'm still like, I guess we're okay. The thing I'm getting confused on is years on average. So if we want to convert this weeks to years, we multiply it by 52. Well, I'm still getting. Wait. Why can't I do this? This should be really easy to do this part. This is the expected value for 1 year, right? Asking how many years on average you have to play to win and retire? $25 choose 7 times 110 times 52. Really? But aren't the numbers changing every week though? I think that's only valid if the numbers are the same. Or I don't know. Yeah, Safan's question kind of fried my brain. I don't know how to get the number that I actually want. It's fair and memoryless. Really? Okay. I feel like the answer is to do 1 over this. I don't remember why though. Like, it's supposed to be a million years. 10 to the 6. Sounds about right. Okay. I don't like. I forget what's the justification for doing that. Ugh. I need to relearn probability at some point. 25, choose 7. We can see if that matches my thing at least. $84? It's a lot different. I mean, 25 to the 7 is tiny, right? Or, well, 1 over 25 to the 7. 10 to the minus 10? Yeah, it should be something that's stupidly long. Like, I feel like a million years is more likely to be right than 84. That's a funny question, K-Pars. Okay. So I've done A and B. Did I LaTeX them both? No worries. Oh, yeah, Lucas. Okay, yeah. I LaTeX them. Oh wait, I didn't finish LaTexing part B. Oh, right. With a reverse sigma operator. Um, my God, this is too many pages, dude. Oh my God, I just hit the wrong button. So the thing with y cubed plus y squared plus y equals x, it really isn't much different at all from x cubed plus x squared plus x. Like, these are really just, they're just letters. They don't actually mean anything. So like, if you wanted to make them like do your normal x and y axes, like, you could graph this cubic, whatever it'll be, something like that, I bet. And this function up here would just be like a reflection. It would be like that. So I'm not sure that you would like, I'm not sure you would need something complicated like a new operator, because it's still just kind of, instead of function y of x, it's a function x of y, but those are just letters, so who cares? The issue with trying to do like in an like, if you have like summation, like, we know that if we have the sum n equals 0 to infinity of 1/2 to the n, there's a formula for this summation. We know it's 1 over 1 minus 1/2, which is 2. And so it sounds like you're asking about some type of like inverse summation like on 2 that would give us like presumably whatever particular type of series we wanted back. Well, I guess how'd that even look? Would it give us this? I guess so. I think the place is looping. 1 second. But the issue is that like I can't really like without yeah that seems maybe more right. But the issue is that like this isn't the only way to express 2 as a sum of things. I could have also said n equals 0. I mean, this is a stupid one, but like n equals 0 to 1 of 2n. That also equals 2. And so like, if all you know is this, how do you know which summation to return? We could we could kind of like restrict it so we always give back summations of a certain type. Like this inverse sigma always gives you back. If you have inverse sigma of y, well, ugh. This is so hard to think about. I don't usually do this with math. I guess inverse sigma of x would give you something like y to the n or something like that. Stooky, good morning. They're going well, yeah. It's been I meant to spend stream work on homework, but there's been like a lot of questions, which is good. Slide at the end of the tunnel for you. Nice. Look forward to thinking about anything else. That's good to hear. You like think about this kind of stuff? Yeah, you definitely should. It's great that you have this like curiosity about math. So the summation that we have is n equals 1 to 3 of y to the n. That equals x. This is the thing that we wrote up here that you originally gave me in summation. So then if we did your inverse summation idea, we would get y to the n equals inverse sigma x. I don't know if this is helpful or not. This is kind of a lot. This is probably equivalent to doing something. Something that doesn't require such weird notation. I think we're basically just isolating y right now, but in a very weird way. I guess so, yeah, but it's like but it's like this n was defined by the sigma and now it's kind of homeless. It's like, what really is this n now? So I think this notation is incomplete, or at least as I understand it, if we take the inverse sigma, we need to deal with this n here because now it's meaningless now. Like we know it should be 1, 2, or 3. But it shouldn't be outside of a sum. Take the average for good measure. Oh god. Yeah, just divide it by n, and then also take the nth root. I'm high on math, collar cone. We're making a new inverse summation. We're trying to. uh it's just some operator such that like our inverse sigma, as we've been calling it, of regular summation of x or whatever is just equal to x. But that there's been many issues with it. So it's a little bit hard to like actually define it. Yeah. I don't think so either. I guess I should say like, oh yeah, I guess yeah, there's a big issue where it should be like x sub n, I guess. Because these aren't all the same thing. So like I don't even know what to say it's equal to now. Like x sub n, it doesn't make sense anymore. We could say it's equal to like a sequence of x's, maybe. Like x1, x2. But yeah, I don't know. Yeah, it definitely like you definitely cannot do it for general summation. But I was thinking you might be able to save it if you always gave back a particular type of sum. Like if you always gave back a geometric series or something. But even then, I'm not sure. So, I don't know, Lucas. This just sucks. It does. It's kind of interesting to find a way to make this work, but summation just feels kind of like one way. It's a pretty hard thing to invert. I don't know if I can. Um, will be a simple one. I don't know. I've never even thinking of what a simple example of this would be. Yeah, like I would just do something like that, but like I don't know, of just n. We know 1 plus 2 plus 3 is 6. So you would need, like, what okay, what do you want inverse sigma of 6 to return? Like, I guess we want 1 plus 2 plus 3. If you think of summation as a function that takes a sequence and gives you a number, this map is clearly not injective, hence no inverse. That's fair, yeah. X log y. I'm not sure that would be. Like, yeah, so I guess like, um, I, I guess this would be expressing like any number as a sum of 3 consecutive numbers. Can we do it for 7? We can't do it for 7. Not every number is a sum of 3 consecutive numbers. Random Talks, thanks for the follow. What's going on? Lucas had an idea to try to make an inverse summation operator where if you have like inverse sum of a sum, you get something that we're not clear on back. I'm still not exactly clear, but only multiples of 3 are sums of 3 consecutive numbers. Oh, that makes sense, Shed. Yeah. One thing you could do is look at a map that takes a sequence a sub n, map it to the formal power series sum a sub n x to the n. Yeah, I guess like fundamentally, Lucas, what Colorcone is saying is that this inverse sigma would probably have to give you back a sequence of numbers, not just a single like thing, but it has to give you a sequence, like the sequence 1, 2, 3. Okay, that's what you said too. And so I guess this would work for multiples of 3. This particular example for inverse sigma, or like inverse sigma of 9. Is that going to be the next one up? 2, 3, 5? No. 2, 3, 4, duh. So that's kind of something for multiples of 3. It is hard. It's hard when you've been doing it for nearly 4 hours in a row. So yeah, no, I've been fully distracted by people's questions since you were here last. um yeah, I think that's all I got for you, Lucas. Sorry, I'm not sure what else to make with this. Is 1, 2, 3, 3 number something? 1, 2, 3 is like, it's like we 1, 2, 3 is what you would sum. So like you would do 1 plus 2 plus 3. It's giving you like the sequence of numbers that goes inside of the summation. So I can keep talking about this, but I might go back to like also working on homework at the same time. Prove useful in number theory. Yeah, there probably is some way of using that number theory. Like as Jed pointed out, these are multiples of 3. I can never remember the different conjectures. Goldbach is the even number sum of 2 primes, or whatever, odd something. Right. Uh, if you think it can help with that, you become pretty famous. Or if you think you could actually like solve it with that. But hey, you know, don't let your dreams be memes. Uh, okay, so this is the example from the book we can cite for the integral of 1 over z. Help, I'm being held prisoner in a Chinese bakery. um Actually, you know what? I want to bring the 1/2 outside of the second integral. From example, gonna go now, gonna try to make some progress for next time on the sigma stuff. Sounds good, Lucas. Thanks for trying me. 2.5.2 on page 88 of Ablowitz and Focas. The second integral becomes 2 pi I. These mathematicians are very weird and interesting to look at. They're definitely weird, I'll give you that. I'm phrasing this terribly. Oops. And this text it's kind of tiny, but I don't know if I can zoom in a little bit, but I want to be able to see. So we conclude slash o int underscore c. Well, yeah, we can just do f of z. No. Of that, dz equals negative pi I. That's what I got on the journal plus plus, right? Yeah. Wait, minus I pi. Do I put pi first or I first? I don't know. I'll put I first. But then 2I pi or 2 pi I? I know. I like 2 pi I, but I like I pi. But that's not consistent. Ugh. You know what? Fine. Let's not be consistent. Those eyes can go wherever they please. All right, and then part C. Part C, 9z over 9z squared minus 1. I'm going to again cheat and use Wolfram Alpha for partial fractions. 9x over 9x squared plus 1. Hey, Phobos. Cheating. Hey, even when the professor had a partial fractions thing in class. Oh, Wolfram Alpha isn't going to partial fractions that. I need to make it Z. Like, he just gave the answer for partial fractions. He didn't do partial fractions by hand in class. That means I'm allowed. Oh no, he's defeating me. I can't cheat. Wolfram Alpha doesn't know how... Damn it. It's even worse. I tried to cheat, but I'm not smart enough to figure out how to cheat in Wolfram Alpha. No, it's not, it's not actually cheating. I'm just trying to have Wolfram Alpha do partial fractions. Oh, do a plus 0i? Maybe. Let's see. Middle bar touches how wide the code versus displayed parts are. Oh, that's true. Yeah. The code is good. I guess that's fine. I can still like write LaTeX in that narrow of a screen. Losing at cheating is hard on the ego. It really is. You know, maybe this is Wolfram Alpha's cheat detection software. Okay. You know what? You know what? No. Wait. Don't worry, guys. I'm gonna hack into the mainframe here. Just write partial fractions. Damn it. Never mind. Partial fractions by hand. I guess. Frickin' Wolfram. Not letting me be lazy. Oh wait, it's -1. Wait, I was doing +1 the entire time. Oh my god. It's because it's just an irreducible quadratic, right? I thought it'd be fine. I don't know. Oh my god, I can be lazy. Oh, hallelujah. I was just writing the wrong thing. It's -1. What was it again? 3 over 2, 3z plus 1. 3 over 2, z plus 1. Ooh, wait. This isn't defined. Excuse me. Oh wait, yes it is. Never mind, I'm stupid. Plus 3 over 2. Z minus 1? Oh wait, oh no, no, that's why I got myself confused. It's 3z plus 1. Three z minus 1. There we go. I thought our contour was going to go through discontinuity, but it's not. I just forgot my 3's. Okay. VR chat stream? That would be huge. Oh, wait. No, I think Stooky means virtual resolution, not virtual reality. Oh, hey. Oh, okay. You would do you would have a virtual resolution chat? I guess I would. I just feel like I would be lost. I don't have VR. I did play VR chat a little bit when it first came out. I'm kind of too awkward though. Tabletop. Oh, Oh, that's right. Yeah, we did the tabletop simulator session once, and then I said I'll get you in for the next one, and then there hasn't been a next one because I don't like organizing things. That will be fun though. I wish I had VR, but even just getting another tabletop simulator session going will be good. VR stream with Cox Ray. That's a good time. It is. Um. Okay, so we have to integrate this thing around the unit circle. We have two singularities. I've got two singularities. Well, really, I mean, there's not two at once though. If we had residues, we would just add up the residues and not have to do partial fractions, right? But we don't have residues yet. No, I wish I did. I would need a better PC and disposable income. And I have neither right now, so. But I think VR is super cool. I'm spacing out right now. I guess do we do a U sub and cite the same result? This feels kind of lame. Like, why can't I just do it directly? Buying a MetaQuest 3 is one of my poorest financial decisions in the last 2 years. Oh, really? Oh, factor the 3. That feels better. You want a big screen beyond 2. Wait, like, you want more than 2 monitors? Or what do you mean? Is MetaQuest 3 bad? Like, I probably want, like, the index or something, but... It's the name of it. Oh! What a weird... Okay. I've not done any research on VR headsets. You have a Vive Pro 2 with index controllers? Oh, nice. The big screen 2 is kind of the go right now? Oh, okay. This is still 2 pi I, right? Yeah, it's 2 pi I. 1/2. Oh, are they gonna cancel? No, they're gonna add because it's addition. Your game is a bit too beta testing at the moment. That's fair. I definitely wouldn't have, even if I could, I wouldn't have wanted to buy VR right when it came out, because it's like when there's anything new like that, it's just better to, unless you're really psyched for it and want to play with it now, you're usually better off just waiting for the technology to get better and cheaper. But it does feel like I feel like VR has not gotten to the better and cheaper place yet. From the and again, I haven't like done any research like recently. It's probably better, but three over two, 3z plus one. Like it best and most for VR chat, just hang out with people. It's cheaper than a car, that's for sure. Three Z minus one. Actually, let's go one step further and cancel the threes already. 2 Z minus slash frac. Plus. Ugh. Two Z minus slash frac 1/3. Not bad. Again, by example 2.5.2. Oh wait, does that example have the offset? Yeah, it does. Okay. There's a Metro game in VR? I didn't hear about that one. Equal to I pi and the same thing but with a minus. So the entire integral slash o int underscore c dz equals. Why don't they do slash frac? I'm a slash frac fan. I'm a fan of fracking, and you can quote me on that. 2 pi I. Played around in Half-Life and Cruise, not really great for you and get motion sickness. Oh, that's fair. It's quite good for a VR game. That's good to hear. You haven't played Metro? Honestly, I've never been able to beat, or like, I've never beaten a Metro game. I have both 2777 2070 70 70. That's Metro 2077, but it's repeating. Metro 2077 and Metro Last Light, the older ones, and I could never beat either of them. Like I kept on starting playthroughs and not sticking with them. Auction man speaking. um, this is the true math. I really want to though, because I love the themes of those games. And just like the settings, but I just for whatever reason could never do it. All right, well we answered one question for complex analysis. That's progress. There's two more. We don't have to do complex analysis though. We also have that's complex analysis. We have more complex analysis. This is the same thing though. We have computational biology, or computational models in biology, whatever. And we also have scientific computing. I don't know if we fully learned the stuff that we need for scientific computing yet, though. I feel like we need to have a few more sessions. Metro Exodus is the best in your opinion? Ooh, okay. I thought about reading the books too at some point. I haven't gotten around to those either though. It's that time of day where the sun shines right in my eyes. Is the author in jail? Metro Books author. Oh shit, I didn't hear about this. This is like relatively recent. Oh, that sucks. Damn, that's a brave dude right there. Yeah, it's like he's living in Russia and criticizing the Russian government, which is brave, but also probably going to get you in trouble. But it's always for a good cause, so I respect it. I kind of want to see if I can figure out this. I want to take a little break from the complex analysis. And I want to think about the biology one for a little bit. Mission Prison, it does not seem like a good place, Jens. No. So this is building on the previous homework, where we built a 50 by 50 matrix that represents okay, I guess let me back up. If you want to have a basic model for a population, you would just have like, some type of exponential function. We're assuming infinite resources here. Or we only really care about like the early behavior, whether they're increasing or decreasing. That's the important bit. Like, is the species in decline or is it increasing? So we only care about like exponential. We don't care about like logistic growth or anything. But that's not the most informative thing. You can get a more informative version of that if you split the population up into like categories, usually by age. And what you get is basically a matrix equation with powers of a matrix that represents your exponential function. And so in this problem, we're dealing with the northern spotted owl, and we're considering them to live until age 50 at most. They could live longer, but we assume they're an insignificant part of the population. And so what we can do is build a big old, oops. How do you, oh, I didn't actually set this up. Is this gonna work now? Ah. Please work. Hey, okay. Mura Yakerson has a funny short story on her website about that one time she was thrown in prison, decided while there to do a PhD. Wow, I didn't know that you could even do a PhD in prison. That's cool though. So yeah, I basically have a giant 50 by 50 matrix. This is the first row of the matrix. This represents the number of newborn owls each year. Or it's at least part of the number of newborn owls of each year. These first three zeros represent how the first 3 years of their life they don't breed. And all 47 entries after that are 0.24, which represents the average number of owls an adult owl gives birth to each year, female. She didn't do it while in prison. She only made a decision to do one. Oh, okay. Wow, what school accepts you fresh out of prison? Or maybe she wasn't like fresh out of prison, but it'd be hard to get into a program. Yeah, and so that's the first row. All the rows after that are determined by kind of like the survival percentages, like what percent of the population survives another year based on their age. So like about 42% of newborn owls survive to the next year is what this entry represents here. Oh, yes. Oh my god, I keep forgetting to tell Dessen. Wow, what the hell? I didn't know that was her. Yeah, I watched an interview with her interviewing Steven Strogatz. And Dessen kept like asking me to watch, and I kept forgetting to, and I finally did, and now I keep forgetting to tell him. Oh, that's crazy. I did not know her backstory. Yeah, I haven't watched any of her other videos, but that seems like she seems like a good interviewer. So we need the matrix of elasticities. So if we're interested in like making, so as it stands now, the population of owls is in decline. And we can determine that by getting what's called the dominant eigenvalue of this matrix. And that's the eigenvalue with the largest magnitude. And it's like either 9.4 or 0.96. So it's below 1, which means the population is in decline. And we want to have an intervention basically change one of the entries in the matrix, or multiple. Like we're gonna take some human intervention to increase the survival rate of these owls somewhere. And we want to know like which entry should we change to have the biggest impact on that eigenvalue. And so we can define eigenvalue sensitivity. And then the issue is that here we don't, but it's possible for the matrix to have very different orders of magnitude in its entries. So if you want to normalize things, we find instead what's called the elasticity, which is the sensitivity times a scaling factor. So we need to find that here. Let me get my notebook. Ina Zakarovich. Okay. What type of math was that about? Oh shoot. I fucked up by not having the example ready. They provided an example of calculating elasticity. And I really should have had that ready if I was going to do this. Okay, well, I think maybe we can figure it out. So I guess we need to start by getting left and right eigenvectors. Okay, so LV equals np.eig. No? Oh wait. It's la.eig. Proj matrix. But we also need LW equals la.eig np.transpose proj matrix. Okay. And so we need to get the dominant one for each of these. And we do that. IDX equals np dot, is it argsort? np.absl. L sorted equals L of IDX. V sorted equals V IDX. W sorted. W IDX. More about life as a mathematician than the math she did in particular. Okay. But Zakarovich did her PhD on some topic in topological K theory under Michael Hopkins. Ooh, okay. That's fancy. Just to see what we get, let's print out L sorted. Hello, that's a lot. Oh yeah, we want the last one. 0.94, that sounds right. Okay, so our S matrix is going to be la.outer, no? np.outer? Yep. W sorted -1 V sorted -1 divided by np dot inner product of the same vectors. V sorted -1. And let's print out S again. Or not again, but... Are we supposed to have complex sensitivities? It shouldn't be complex. Why is it complex? It's weird. I think it's supposed to be a real eigenvector. Did it give me the eigen values in different orders between these two things? No, they're both imaginary or complex. Bruh. So this feels all sorts of wrong. Algebraic K-theory? Honestly, I couldn't tell you the difference anyway, so that's okay with me. um... This... Our dominant eigenvector should not be complex. It shouldn't have any complex entries, I don't think. Excuse me. What? Why are you complaining that I was running this code up here? Why are you complaining down here? Wait, does it not have the right shape? Oh, it sure doesn't. Turns out commas and decimals aren't the same thing. Oh, okay, yeah. No, it should start out as being real. Or like, it's still like, if it's not... So the eigenvalue is real, that's good. But if the eigenvector isn't real also, it's just not a physical situation, I don't think. Yeah, the owls are doomed to be imaginary. Won't someone please think of the owls? Well, damn it. I'm thinking, but it's not working. I guess I'll have to come back to this one and just look at the example, because there's no reason this shouldn't work. 0 there, that's good. Yeah, I don't know. It's not like, I honestly don't know what this could be. We could try this other unrelated problem, I guess. Okay, this right here is like the base question, and then these are modifications. So consider possible harvest from the killer whale population. Suppose the initial population structure is stable distribution W. This is the dominant left eigenvector. 250 individuals. What is the maximum number of juveniles that can be taken each year? Population is not driven to extinction. Why are they hunting juveniles? That sounds kind of mean. What's the maximum number of reproductive adults? Can there be a negative number of individuals? Was that a risk? I would hope that that's not a risk if you set it up right, but okay. Okay. Doesn't seem like the end of the world. So we do need our initial values, calling n 0. They're all just 250? Initial population structure is stable distribution W with a total of 250 individuals. Oh, damn it, we need to find it. Okay. Okay, so LW. LA.ig AMAT. NP.transpose. Wait, we can do .t. I forgot. That's shorthand for transpose. Should do that up here too. Okay, so we do need to get... Hopefully this one doesn't come out to be complex also. IDX equals np.argsort np.abs of our lambdas. Now we're going to do L sorted equals L IDX. That's not X, that's X. W sorted equals W IDX. Okay, and so let's print L sorted -1 and W sorted -1. They're on the come up. their dominant lambda is above 1, and we're getting a real left eigenvector. Thank God. Okay. And so this is also... Oh wait, why did they use W for that? That should be V. Am I stupid? Wait. They're using V for stable distribution. I thought. Wait. W is the reproductive value. Yes, I thought. Maybe they're just saying W is a generic eigenvector. Oh, really? I guess I'm stupid. So W1 is a dominant eigenvector, not left eigenvector. Hey, XFret. How's it going? Are we seriously using V for left eigenvector? No. I'm getting my letters mixed up. Oh my god, I am. I wonder if that made an issue earlier in the code up here. This is for a class for mathematical biology. It's called like computational models in biology. And yeah, you got it right for dominant eigenvector. And so the left eigenvector is an eigenvector for A transpose. And that's important because it has an interpretation in this context. The left eigenvector would tell you, I guess, like the matrix that we have. I have to like explain this from the start. But like, it's basically this: we're modeling a population, but they're split into stages. In this case, by age. So like, in this case, we have 4 like categories of age, and we're tracking their overall population and how they transition from one stage to the next. Yeah, exactly. And so you get matrix exponentiation for your like model. Hey Mo, hope you're doing well. And so yeah, like the right eigenvectors tells you your the right dominant eigenvector tells you the long term for large T, the distribution of like the population inside of the category, like what percent is in stage 1, what percent is in stage 2, and so on. The left eigenvector, the dominant left eigenvector tells you, they call it reproductive value, which is like if you're going to invest into like just one category to try to increase the population, which one is the most important for like reproduction. But then there's another thing we can do, which is figure out the sensitivity of the eigenvalues with regard to each of the entries in the matrix if we wanted to try and like, you know, bring population from declining to increasing. And so this question is actually, what is this question doing? No, this question is doing something else. But in the question before, we were trying to get like eigenvalue sensitivity. and I kept screwing it up, so I just moved on because I was doing something wrong. Yeah, exactly. But for this one, kind of we're changing the model a little bit, and I guess seeing what comes out of it. So what do I have? Okay, so I got the left eigenvector, the left dominant eigenvector, but I think I actually needed the right one, and I'm just getting my letters mixed up. So I think that should not be transpose. Okay, and so all this is in the name of n0 equals 250 times w sorted minus 1. I want to print n0 to see if I want to make sure this thing is behaving how I think it is. That is not what I wanted. Ugh. Maximum the sum of HIs? We're not summing the HIs with each other. The H's, how many juvenile whales we're killing each year for sport and enjoyment. Because we're just that type of person, I guess. The maximum number of juveniles each year be taken such population is not driven to extinction. I guess we're trying to harvest the most number. We're trying to find like an optimal H, I guess. That's what we're doing. Like, how large can we make H while the population is still increasing and not declining? $168 is a wonderful number, is it? It's one off from a perfect square, which kind of bugs me. Oh, wait. I'm misinterpreting H. I thought H was only going to be in one of the stages. H is a vector of the number maximizing the sum of HIs. Oh, I guess you're right. Sorry. I guess we are maximizing the sum of HIs with a condition. I guess the condition that the dominant eigenvalue is still more than 1. It's the order of the second smallest non-abelian simple group. Sounds kind of complicated to me. I don't know what I've hardly done any abstract algebra. I don't know what simple group actually is, to be honest. This is bad. W sorted minus 1. Why? This isn't possible. Why? Dude. Ah! What am I doing wrong? Which math god did I piss off? I don't know how to get eigenvectors apparently, because this can't be right. Simple groups are like the primes of group theory. Fair enough. We definitely shouldn't be having a negative number here. The 0 we probably shouldn't have either. But this is supposed to be a vector representing the long-term distribution of killer whales within each stage. It should add to 1. It might add to 1, to be honest, but I shouldn't have a negative number in here. Make sure I copied the matrix down right. If I can't figure this one out either, I'm just gonna not do this homework right now and look at the examples that we're given off stream. This is like, I feel like nothing is working right. Hey, Geody. Under 144, 468. Fair enough. Automorphisms of the phanoplane? Okay, I think I copied it down right. Because of complex eigenvalues, we shouldn't. It's possible, like, we only ever, for a physical situation like this, we should always get that the dominant eigenvalue is a positive number. There's the Perrin-Frobenius theorem that guarantees that for certain matrices. We could check that with this matrix. It's a simple formula. Where is it? Project that doesn't make sense. Like athletes prime, you know, it's like a problem compared to others that is kind of hard. I'm not sure what that means, Geody, but good luck. Here it is. Why don't they call it? Okay, yeah. And so this is the condition that we can check. Yeah, this book is really cool so far. Because n is just the size of a. So n squared minus 2n plus 2. How do you do a power? I think I don't know. Is this going to be element wise? That's element wise power. Is it? Oh my god. There's a function for this numpy matrix power. I'll do it from linalg. Duh. Highest level math that I took in high school, calculus BC, which is really what? I don't want fractional power. Calculus BC is integration and differentiation. And yeah, I'm doing some coding. Hey, Smooth Space Oddity. It's going well. How about you? Welcome in. Now, why isn't matrix power auto-completing for me? I was worried that normal star star would be element-wise power. Okay, I'm just gonna write in matrix power and see if it runs. I don't know why it's not auto-completing. I'm scared. A mat 4 squared minus 2 times 4. Was it plus 2? Where is it? Yeah. Okay. Nope, it doesn't know. It's going great. Finished writing paper, going on number 2. Nice, nice. Did I print? I think I printed the eigenvalue. Let me see. Okay, yeah. 1.02 seems like a reasonable dominant eigenvalue. I've been switching around. This is Python, GOD. I'm like halfway to just moving on from this one because for a reason things just aren't working right for me right now. But this is for a class I'm taking called Models in Computational Biology. And so this is like a kind of linear algebra applied to population modeling. Oh, nice. GOD. I keep on getting things that don't make any sense though, and I don't know what I'm doing wrong right now. So I'm about to switch to another class, but I want to see if I can get this working better. Yeah, I think this class has been super cool so far. Like, so if I can actually, well, this question feels a little like messed up, but if I'd actually complete this question, I would be able to answer, for this population of killer whales, how many could we hunt each year while their population is still increasing? Which just feels a little bit cold, but this is the question before this was about like this population of owls that's in decline, figuring out at what stage in their life you should intervene to have the greatest effect on turning the population around. Matthew, thank you so much for the prime. I know it's not quite assembly language. This is like the opposite of assembly language, to be honest, with Python. I appreciate it though. Thank you. W sorted, yeah, and a 0, which, yeah, they should all be positive in between 0 and 1. I really, this is so annoying. It's because W is a list of, or an array of all the eigenvectors. And we sort them by magnitude of eigenvalue. And that sorts them in ascending order. So if we want the dominant one, we take the last one. L is eigenvalues, W is eigenvectors, right. Geometric measure theory, oh nice. I know nothing about that, but at some point in my life, I'd like to learn a bit about measure theory. So right now, I'm working on Masters in Applied Math. This is actually like homework for that. But yeah, if you didn't know, there's a whole little community of people here on Twitch who do math streams. List kind of keeps getting longer. Expert has done a math stream or two as well. But yeah, in case you're interested in like this niche on Twitch, like we're out here. Whenever I see a new face, I just like to like let them know that this niche exists because it'd be nice to like grow it. So cool. See those high level math people in chat. Yeah, it is cool. I'm feeling very low level with my inability to get a freaking eigenvector for a matrix though. Like it's just not getting the numbers that I expected to get. Oh yeah, feel free to, Stooky. I think it's all up to date. Oh wait, why does some have Wait, some of the links have HTTPS and some don't. That's gonna bother me. Oh, the original like 5. Yeah, okay. I'm not gonna be able to unsee that. Okay, I'll fix that after the stream though. So okay, in my math streamer's like command, some of those links have HTTPS and some don't, and just a lack of consistency is bothering me. It doesn't feel like a mistake that I would make, but I definitely did. So cool, I've managed to unify 2 perspectives on multi-dimensional integration. The geometric one based on hypersurface decompositions and a probabilistic one based on expectation identities. Ooh, that's crazy. Huh. You know, he's not actually on the list because he hasn't been streaming like a ton recently, but Ren, I know. Oh no, I got his name wrong. What is Ren's name? I swear it was that. Is there no under? Oh, there's no underscore. There we go. Thank you, Stooky. As for people on Twitch, he's one who comes to mind as like being the most into measure theory. If you want someone who's like actually like knowledgeable to talk to about it too. He was just recently streaming Ghost of Tsushima, and I'm sure he'd be happy to like talk about it too. Arcsort. No, I'm pretty sure it's doing ascending. That's how we were always doing this. He has been, yeah, Fembox. But yeah, I mean, feel free to share it here too. I just like feel bad that I don't know the first thing about. Well, I know like the very first idea of measure theory, but like that's about it, I guess. We can print out L sorted. Smallest, second smallest, third smallest, biggest. That's a weird way of it. Yeah, so it's working right. That piece. It's just the vectors that have been wrong in each of these, and I don't get why. Basically, Mega. Honestly, the thing that came to mind was the measure of rationals is 0. The measure of irrationals is 1. But I guess maybe I know 2 things about measure theory then. If those both count as things. The Measure of a Man is a great Star Trek. The Next Generation episode. I never watched a single Star Trek. But yeah, so that's also sorted right there. Nerd Card Revoked, I know. I'd never seen Lord of the Rings either. And my mom like loves it too. So I blame her for not showing me Lord of the Rings as a kid. W sorted is the list of eigenvectors sorted. This eigen function gives you the eigenvalues and eigenvectors in the corresponding order. Oh, like if I print it. I was just wondering if there's some weird transpose thing. Like if the eigenvectors are actually rows instead of columns. I guess they are rows, and that's what we're doing. I don't have. I mean, I have examples of this on my computer. I just can't easily get to them. Like it seems like this one right here is probably the reasonable. Well, actually, no. I don't know what's up with that one. But yeah, like this one seems like the one that we actually want. Why is it? Why is it not going in the order that we want then? Oh yeah, I mean that's where you would be the most likely to find him. Print L, print W. That's a good idea. So yeah, it is the second one and the second one. So why is it not extra? You must be on to something here. Why is this not sorting? I've done this so many times. Is it the IDX? It must be the 320. What? Oh no. That's what you want to call it, maybe. Yeah. Uh, it's the ABS. I think it's chopping off. W eigenvectors. It's the arg sort, I think, that's messing things up. Because that's not the right order of indices. It's saying this. Actually, wait, is it? No, it is the right order of indices. Oh, I'm sorry. I keep misinterpreting that question. One. So no, argsort is doing the right thing. It's this line that's not doing the right thing. Why? The sort just isn't sorting. Wait, what? Oh wait, these are rows. Oh no, I'm sorry. The eigenvectors go in rows, I think. We've been reading columns, but it's supposed to be rows. It is leaving a lot of sorts, yeah. Ugh. Yeah, it does. These all have a negative entry. That, that's so annoying. I think maybe we just go back to complex analysis. Because this is like something fucky is happening here. Like I did. I have the screenshot from the book open, like right to the side here. Ugh. That'll be a problem for off stream, Don. All right, so we answered number one at some point on stream. It's all a blur now. Go to number two. Does it need to be transposed? No. Yeah, I don't know. It's probably something really simple that I'm just not remembering right now. Ugh, okay. F is even, single valued, complex analytic, except perhaps at a single point z equals 0. Perhaps. Okay. Ooh. I think we need cases. Because if it's analytic, this is really easy. But if f of z is not analytic and z equals 0, then something. This is like the interesting part of the question. Even. Must be something about being even. I think it's going to be we split the circle in half. Ooh. If our original contour is like this, if f is an even function, it should be equivalent to evaluate it. This is kind of awkward to draw. Around this contour. But these are really on top of each other, which is why it's hard to draw. And these would cancel out. Is that the idea? Um, is there like, can we show this with math and not pictures? Um, Equivalent of a U sub. Okay. Oh, I guess like polar coordinates. Maybe we can split it up into two separate contours first. We'll say C1, C2. Let Z equal, they say some contour C. I think regardless, we can just make it the unit circle. Because the only point that's in contention for analyticity is 0. You think it's 67? That's a great guess, Canalito. Welcome in. I think more that if we replace Z with minus Z, it's going to be equivalent to go around the circle the other way. Should give the integral equals the negative of the integral. Ooh. Ooh. That's a lot simpler. Thank you, Canalito. If we replace f of z with minus z. Yes. So can we say like this is always true for any function? With a minus c there? I think so. Just for this particular choice of C, maybe. I feel like this might need... I'd want to justify this statement a little bit more, but this would give us what we want. Because by evenness, that piece is f of z. And by properties of integrals, we can just stick a negative sign out in front and make it positive c. The curve that's preserved under negation. Yeah, that's what I was debating. Like, if it was like some generic line like that, it's probably not true. But it is a closed contour. And because it's analytic everywhere else, we can make it the unit circle. And it'd be the same as any other contour that encloses 0. So we can make the claim, at least for this particular choice of C, that the unit circle is symmetric under this like reflection with minus Z. Which, if f of z is minus z, like a point, I guess that's like getting reflected diagonally across. Like a point in quadrant 1 would get reflected to quadrant 3. Would the orientation stay the same? Or, well, no, or I'm saying it wouldn't. Ugh. No, I don't know if I can justify this equality. It will give me what I want. It should be true for this problem. I don't know if I can explain it, though. What does this mean? Maybe we need to use... Or, could we just skip straight to calling this just f of z? No. I'm sure there's a nice way of justifying that. I kind of want to see if my original idea could also work, because I'd be able to actually explain that. It's just like something fundamental about line integrals and symmetry that I need to understand better. Going around the contour the other way. No, yeah, I don't know. So C1 would be from, I guess, minus pi over 2 to pi over 2. This right here is where I was hoping to mess with Uh, mess with the bounds here to... Well, I guess... Oh, that's kind of a problem, though. That's not even. Hmm. Maybe this isn't simpler. But it's maybe getting at the same type of issue with, like, how do we justify... I mean... at every point on these two contours, f of z has the exact same value because it's even. Wait. Is an even function in complex numbers that is not visually the same thing as an even function of real numbers? I'm thinking about this wrong. I think I said it before. I think if it's even... No, wait. What type of symmetry... How does that look in the complex plane? Even symmetry. It means if I plug in a number... If I plug in a number here, I will get the same output as if I plug in the corresponding number down here. Both of these points would map to the same point like anywhere else. That's what it means for f of z to equal no, even is f of z equal f of minus no f of minus z equals f of z. Yeah. So I'm splitting my contours up the wrong way. No worries. Because I was blindly using like imagine that even had the same thing as like a real variable, but no. Okay, I am fundamentally misunderstanding this problem. So really the corresponding pieces we need to split up into quarters, I guess. Which means I'm really preferring the like Megas idea now because this is making the integral a lot more complicated, but right, yeah. For odd. So theoretically these two bits are equal to each other. And same with the other two diagonal bits. Ooh, wait, okay, maybe I might have the idea now. Okay. It still feels kind of inelegant because I'm going to be splitting up into 4 pieces. But I think I know how I can make this work. Get rid of that. Okay, so C1 goes from 0 to pi over 2. Territory, that's what... I'm not sure. I think it must be true, but I've been having a hard time justifying why. That's basically an idea that, like, Megalomorph put in chat, and it would give us the exact thing that we want. But I couldn't quite justify it. So I was going to do my, like, caveman math and split it up into 4 pieces. Which I'm going to do that regardless because I want to make sure that it works. But I do think there's a way slicker way of proving this than splitting up into 4 pieces. Oh, I guess framing it like a U sub might help me justify it. So if I let U equal minus Z, du is minus dz. Can I would hate to do this. Can I just make this into Z's though? Because this would nearly be the thing that we want too, right? If Z runs along C, U must run along minus C. Well, isn't this going to be bad then? I don't know if we can actually do U sub stuff the way I want. Yeah, I mean, I want it to be true too. I think like there's no reason you couldn't do a U sub here as long as you change the path also. And I think the unit circle wouldn't change. Would the orientation even change? Territory is saying it would. I don't know though. One confusing point here is some people use minus C to denote the opposite of the path, reversing the orientation. Right, that's what I am trying to mean it as. More relevant here is the negation of the image of the path. That's fair, Jens, yeah. The orientation does not change, you start on the opposite side. I mean, I wouldn't want the orientation to change, I think, for... This feels like it's one step away from just being added to the left side here. And then divide out the 2 to get 0. But I just... I want to say U is just a letter and change it back into Z, but that doesn't feel valid. See, I don't know. That's the point issue. Like, I think this is right, or at least half right. I can't fully explain it, which is why I keep coming back to my caveman idea. So then we could substitute z equals minus y of t for t in 0, 1. Oh, isn't actually like parameterize the path? I guess is what I've been doing with this thing here. But not the same way. I don't know. Let me just see if I can figure out the caveman way. The thing that I want to say is that 0 to pi over 2, this bit here, is the same as pi to 3 pi over 2, that bit there, by evenness. If it were meromorphic, we could show with Laurent series that the residue is 0 if we're even, but we can't assume that. So I definitely the problem is true. Okay. My idea with this was something. I guess that we've basically... Oh. I guess it was to hope that when this integral is evaluated at the endpoints, I could show that they're opposite, or like that they cancel to 0. I don't know if I can actually justify that now that I think about it, though. Oh, yes, I can. Can I? I guess we'll find out. E to the I pi is -1. Integral. Ah, damn it! I can't actually integrate this. I forgot. I'm stupid. Fuck. Okay, never mind. I don't know. Yeah, we don't know anything about the singularity. It's unfortunate. Integral over 0 to 1 f of y t y prime t dt. Let's see, Tartar. So 0 to 1 f of y of t y prime dt, just for some parameterization y, sure. Then by evenness is equal to this, sure. What is this doing for us? Like, this again feels like it's a good start, but it's just like I need to understand what the negative sign does to this parameterization, I guess. And this question is getting the old noggin going. It's just not going to the right place. Maybe I can justify that the orientation gets flipped. I'm trying to revive this idea here. So if I tried to like kind of discretize the path, just so we have some example points to work with, let's just say that's T0, T1, T2. Oh, no, that doesn't work. That's the same orientation. I was going to say that T0 would get mapped over here, and then T1 would get mapped over here, and then T2 would get mapped over here, and that I'd be building up a different orientation, but this is the same one. So actually, I feel like I've justified that the orientation doesn't change. Which would blow a hole in that. The integral of the orientation is flipped. T substitute z equals minus y of t. Well, if you're talking about like this here, I don't know if this is a true statement. I think it should be, but I don't know. Oh, hey, okay. So this might be this might be the play here, Territar. This is making sense to me, I think. Because now by evenness, we can justify this being y of t, y prime of t, and now we've gotten back to the original contour integral. But with a minus sign in front. I think this works. It's true if the integral depends only on the image of the path, which we can try to justify. I mean, yeah, it should only depend on the image if it's 0, right? The orientation shouldn't matter. I really like Territar's idea right here, where just let y of t be whatever your parameterization is for a generic curve. And let the signs work themselves out. So I think this is just an answer right here. I mean, with 1 or 2 extra steps at the end, but side substitutes. Yeah. Nice job, Territar. I think there's like more to this question to explore, but I like this answer. I understand it. I could explain it for myself. It doesn't involve splitting up into 4 different integrals. that doesn't even actually work. I mean, would we even need that though, Territar? Like, we get rid of the negative sign anyway. Oh yeah. Sorry, you're right. Oh wait, did I miss? Oh no, wait. Don't crack the champagne open too soon. Wait, fuck. Uh, if y of t is in C, then minus y of t is in minus C. I think that's true, at least for like a circle centered at the origin. I can't imagine that would be true in general, but yes. So, shoot, I need to be... So y of t is the unit circle parameterized, and my counterclockwise. Minus y of t is clockwise. I can't just... Oh my god. Well, no, then I made a bad step here then. I'm about to just stop cooking because I'm getting tired. But I went back to complex analysis. We've been hacking away at this question. About to crash out. I keep getting like annoyingly close to answering it and then realizing there's a flaw. Um, in what I did. U of z is minus z. Consider the image of c under u of z. It should be the same, I think, Territar. Like the same circle and the same orientation. Well, that's what I thought at first, Territar, but I'm not so convinced anymore. Got the extra negative on the right side. Well, if there's an extra negative on the right side, aren't you saying that they're both oriented positively then? Like it's both positive C? Hmm. Uh, sort of? Not necessarily small. I was looking at the unit circle. One of my ideas was to split up into 4 pieces. Because there's symmetry with it being even. But I didn't get something that I knew how to evaluate. But if there's like an epsilon's going to 0, would that change something? I don't know. So I think this is what Territar is saying for the first step. Which this is, like, I can definitely see this equality, just properties of integrals for that bit, and then even function for that bit. Well, Territar is using U's over here, but I mean, I don't know about that. You might be right, Territar. I'm just, it's all coming back to the same question of how the hell this thing actually maps. I'm a little weirded out by how you have, you're holding U of z equal minus z. Hmm. I think this is one of those ones where the answer key is going to be like a 2-line answer with very little explanation. And my answer is going to be something really in-depth and complicated. I don't. I think I might just call it. I'm getting pretty mentally tired. It's getting hard for me to have much of a thought right now at all. Did I LaTeX up part C? I did. Okay, good. Yeah. If anyone has an idea for this one, feel free to post it in the Discord or something, because I'm gonna have to keep on thinking about it. But I think I need to not think for a while. But oh no, the scene. So I'll cut the YouTube stream up here. Territar, who's here on YouTube, thanks for being here. I appreciate the help, Territar. And I'll see you later, YouTube.